Well, welcome back, some of you. I didn't scare everybody away. So, are you ready for the afternoon? Everybody enjoy lunch? See? Okay. All right. So, your next speaker is me. So, I guess I'll do an introduction. Hi, I'm Tom Anschutz. I work for AT&T and have for one or more, maybe 3 or 4 different kinds of companies that call themselves AT&T at one point or another. I've been around a long time, and I've worked on all kinds of things. Worked on everything from PBXs and ISDN through ATM forum, through standards and web hosting services. I was the product manager for Easy World Wide Web, if anybody remembers that from the late 90s. And now I have the sort of this wonderful position of being paid to come to work and do something that I find completely fascinating and invigorating in ways. You know, coming to work is much more fun than it has been in years in telecom. I'm telling you that. So I'm active both in ONF and in OCP. My company is also, really active in Linux Foundation. I'm going like this, but Heather's missing over there. And we're, as a company and personally, we're very committed and strong believers in community and open source. So why don't I start now with my talk, and we're going to talk a little bit more about OpenEdge and a little bit about convergence. Now, if you've been in standards and you've been in the industry, and especially if you're one of these Gs, a 5G or a 4G or a 3GPP, then convergence used to mean a lot of standardization and a lot of sort of agreement to do everything our way. And I don't think that that's the convergence I'm going to talk about today. That may happen, but I think there's a much more immediate and interesting approach to convergence that has almost all of the benefits and none of the downside. So why don't we get started? There, that works. So I'm going to start off with OpenEdge, and this is sort of the basis I'm going to build the talk around. You guys saw the talk. How many remember the talk this morning about OpenEdge? Good, you're at least awake. All right, so we talked about OpenEdge this morning, and it was really interesting from a number of aspects. One is that it is open. Anybody can come and make or add to or change or modify, or it's like open source. You get the source, and you can do with it more or less what you please. Same here with OpenEdge. Anyone can build it, anyone can build upon it, and a lot of OCP members are interested in kind of making this a basis for things that would be deployed at the edge of carrier networks. And the good news is, at the edge of carrier networks, there are a bunch of interesting requirements, and they're largely met by OpenEdge. We might find some more, and we might build something to deal with that. One of the things I liked about it is a question that came up this morning, and I forgot which guy it was, but asked, yes, I remember you now. You were asking about the bus or the user plane between the compute sleds, and there is not one, right? There's only power and management interfaces connected among these different sleds. And that, we've lived through ATCA, and we found that a lot of times it was not as open or as reusable a chassis as we would have liked, because as technologies went faster, the backplane became, old and needed to be updated with new technologies to deal with new speeds. So it doesn't try to do that. It leaves the interconnect among servers at the job of a top-of-rack switch, or perhaps a switch that I'll get to in a page or two, where it's the cheapest bandwidth on the planet. So thinking about a fabric that's at the top of rack as opposed to trying to build something bespoke into the chassis, I think has a lot of economic and long-term benefits for not getting out of date. So it also is fine for CO and cell site deployments. Most cell sites and COs, cell sites that are type 1, would have temperature ranges from -5 to 50 or 55 degrees. And and it fits into that bill. Now, it's not your typical data center server, but it is something that's it's attractable with today's designs and technologies without having to go to what I'd call extreme or expensive measures in order to support it. And one of the important things too is that it lets you get started with OCP without going all in. And what we've seen for years, there's been an OCP rack spec. It's been, the whole rack, open rack. How many people, does people know what open rack is? Okay, so the open rack has some really fundamental benefits. Having a power shelf that feeds individual servers winds up giving you a tremendous boost in the overall power efficiency of that shelf. When you have individual power supplies and servers, they wind up usually not being used in the sweet spot of their efficiency, and it ruins it for the whole thing. Also, the open rack typically is used by web scale operators, and usually the way they deal with something is if a server breaks, they don't do anything. Logically, it's taken out of the myriad set of servers that they have, and at the time when it's time to rev or move to the next server platform, they'll take the entire rack out and roll another rack in, what they call rack and roll operations. And so that's really good because you don't have people in your company, if you're a web scale company, who are sitting there fiddling with all of the connectors and power supply connections and so forth. So it's a really good operation story from that perspective. It's not exactly how things work today in telco, right? So today, a lot of these racks, especially the big ones, wouldn't fit through the elevators or the doorways, and in some places they would overload the floors in places that we want to put computing. And so it's been really hard to adapt open rack. And there was also a carrier grade rack 19. Once again, similar, it's not 21 inches, it's 19 inches, but it has the same bus bar and the same power shelf, and was a really good solution in that space. But once again, it's rack scale space is not quite where carriers are at. And importantly, in a place like a cell site where you may have an existing enclosure and the expense to change out the entire enclosure would be phenomenal. It's sitting on a concrete pad. It's been built like a building, not like putting a rack into a data center. And so being able to fit into the existing spaces that are at cell sites and are at the serving offices without having to change them into data centers is a benefit. And in a lot of ways, I think that this OpenEdge chassis is a great opportunity because it can go into those spaces where a lot of the other designs that we've worked on, frankly, couldn't go. It's not to say it's going to be the panacea or the solve-all. I'm not sure I would put this into large-scale data centers. They've been built the way they are built for a reason. But at the edge of the network, this looks very, very good. Okay. So obviously, it can be deployed. I just finished the story about how it can be deployed to places without having to retrofit them. It today provides two kinds of servers, a single rack unit and a double rack unit that can hold a large video acceleration card. But the rack itself, the chassis, or I don't know whether they call it a rack or a chassis, someone was asking me that earlier. The box, the thingy, can actually do more than just host servers, right? It's all you have in the back is power and management, which is something you always want. But you can imagine in small deployments where there's not a lot of equipment that needs to go into a place, that it might make sense to put other things into the chassis. So the first no-brainer is what about switching, right? So today, switches are top-of-rack switches. You usually duplicate them for redundancy, and then there might be a third switch for management. Well, if you only need to have two of these chassis, there may not be a need for two top-of-rack switches. That might be too much. And the management switch, if you remember the discussion from earlier, can be daisy-chained without having a physical switch at all. So that looks pretty good. we AT&T are very interested in using this as using these technologies, SDN, NFV, and OCP, to attack our wireline access. And indeed, we have some specs underway. Sumitra, can I get you to stand up? I'm going to put you in the spotlight. So Sumitra is our person who's working on our OCP. Thank you. Our OCP spec for XGS-PON, and has been working on form factors up until now that were different, but we believe that moving to this form factor might be an extremely positive thing. So there's access. We've got server, then we've got switch, and now we've got wireline access. And of course, you know, the last one is you can also do wireless access through these type of environments, especially if you're able to deploy them in cell sites. So all of these things come together, and what you gain out of trying to make things fit into this common space or chassis is that operations can actually be attacked in a new kind of way. So today, if you look at most deployments and most telcos, it's a variety of boxes. We used to call them vertically integrated boxes from lots of favorite vendors, and they are all operated differently. In fact, each one of them comes with its own element management system. The element management systems have to be worked back into network management systems and operation support systems, and I can go on. The systems go on and on and on, actually, and they wind up being, most of the time, more expensive than the box was at the end of the day. So introducing a new, unique thing in the network is a very expensive proposition from an operations perspective. If you can introduce new things without changing how you manage them, how you work with them, how they tell about performance or operational errors, then you can make gains that either you'll be able to minimize the changes in your IT stack, or in a really perfect world, you might be able to eliminate them entirely. So one of the things that started off and now in the OCP community, so this is not Nokia, this is the OCP community jumping on, is to work with the rack manager controller. So it's a very small processor, you know, a little ARM chip that winds up talking to the power supplies and the fans and to the other, and can talk to the other compute platforms in that rack. And it allows you to create a common profile, common management interface for a broad variety of things that would fit in the chassis. And this, I think, is another one of those tools that'll help us to create a cheaper, more uniform, and more straightforward operations environment. All right, so here's the picture. What else, you know, we came into this and we saw the chassis. We know that it can support a number of servers. What else can it do? And we've talked about GPUs and accelerators. That's already handled in the 2 rack unit server model. We've talked about switches. We've talked about access, and there could be other things. So let's dive into that a little bit. I just put Sumitra on the spot, and now I've also taken some liberties with Photoshop and created a sort of an artist's rendition on what could be a 16-port, 10 and 25 gig XGS-PON sled for this for this device. If you recognize, yeah. So apologies if I photoshopped your device. And it has 400 gig uplinks. The system is non-blocking. If you add up all of the bandwidth for the access and all the uplinks, this doesn't have to be a concern of anybody for traffic engineering. Another operational simplification. We're also underway at OCP and have introduced the notion of creating a spec for a front haul switch. And front haul switches are used in a 5E architecture, 5G, sorry. 5E was an old architecture. In the 5G architecture, somebody got it. Thank you. Yeah, right? All right, so, come on, get on the rails, Tom. So in the 5G architecture, the radios in cell sites are pulled together over high-speed links called CPRI, or radio over Ethernet, or eCPRI. And the forwarding and framing requirements look a lot less like Ethernet and more like TDM if you're as old as I am, but we'll call it Ethernet. You still have to have all kinds of interesting scheduling functions, and so you need new kinds of silicon to support it. So we're interested in creating another spec for OCP to create white boxes that would do this type of front haul switching and interworking. So you can take a CPRI radio that might be deployed today for 4G LTE, you can interwork it with radio over Ethernet to go back to your common baseband pools, your G node Bs and your E node Bs. And then of course there's also the Tor switch. You do need to interconnect the compute that's in here, and you need to interconnect that with the access and other technologies that are there. And I've shamelessly stolen some pictures from existing products that are already 1 RU and half width and shallow depth. They're already on the market, so I don't expect that they would be extremely difficult to design an OCP variation that would allow for these things to fit into the same chassis and provide either 100 gig interfaces or 100 uplinks and 25 gig interfaces. All right, so then there's OpenSpec servers. There already are 2 that have been brought forward by Nokia to become OCP inspired, and they meet the basic ONF SEBA use case, which we'll hear about, I think, in a little bit. And they also meet, we believe, we believe they meet the ORAN and also potentially the OTII use cases for servers that would be used for software RAN in the future. They are single socket today. They focus on power efficiency. And maybe I should spend a moment saying, if people don't already know, single socket is actually easier for high I/O workloads to deal with. That a lot of times the NUMA architectures and 2-socket servers put all the I/O on one NUMA node, and then you've got an extra processor sitting off on the side. So that makes it very difficult if your main purpose for the server is to move packets in and out. Going over to a second NUMA node doesn't make a lot of sense. So they make servers that have balanced I/O against the 2 NUMA nodes. Each socket then has I/O to different Ethernet cards typically. But guess what? You still architect your application software to think of it as 2 servers. There's this processor with its I/O, and there's this processor with this I/O. Why bother? And so, you know, the single socket server never has that problem. You're never going to pin to a core that's on the wrong NUMA node. Problem solved. And so it does also help with focusing on efficiency, that single socket servers allow you to make use of some of the most efficient processors that are on the market from all of the suppliers, whether it's Intel or AMD or ARM or what have you. They're good at that space. And scaling down is sometimes the thing you need to do. So for example, in wireline access for AT&T, the SEBA thing you're going to hear about this afternoon, we have the need for 3 servers to maintain the availability, what would you call it, the reliability architecture of the back-end databases. They sort of elect who's gone insane and then keep the other 2 alive. That's oversimplifying a lot, but you get it. But they don't need to be ginormous servers. 3 very modest servers would do. And so sometimes the problem, if we're going to deploy something in a smaller office, is actually finding a way to get something very small that still looks, from an operations perspective to the software in this case, like you have many servers, but it's very modest in terms of the size of those things. Okay, and then I talked a little bit about operations, and this common operations surface is one of those areas that we're very interested in. How can you make sure that when you have the next sled that comes along, that the basic underlying things, your onboarding, your inventory, your management of the power and the fans, and whether there's a fault on board, all happens in a very regular way, and that's a big benefit. So, all right, now you've heard twice about OpenEdge. Now why don't we break into some new ground? What about convergence? What does this mean about convergence and what do you mean by convergence anyway. So I'm going to pick on another one of our little favorite projects, some work that we're doing at ONF, but the concept of multi-access or multi-edge or multi-use cloud at the edge is by no means located in just one organization or open source community. It's pretty much on everybody's mind these days. Well, some of the basic tenets of what you want to do at the very edge of the network include making use of white box infrastructure, being able to reuse infrastructure for more than one workload or purpose, and to disaggregate. What we found is that if you had VNFs that looked just like the vertically integrated boxes before, there was not a lot of reuse. I could have two VNFs. One could be a broadband network gateway, a BNG. One could be a SAE gateway for wireless. They're both gateways. They both apply customer policies. They both do, if you fuzz your eyes over and look from 40,000 feet, they look like the same thing. But the VNFs were not reusable in the adjacent market. I couldn't get a VNF for a BNG and use it for a 5G. I couldn't get an SAE gateway and use it for wireline. So what happens though if I break that or if I disaggregate those gateways and tease them apart? Well, inside, I find that there's something terminating layer 2 protocols, whether it's GTP or VLANs. I've got another thing that's applying policies based on something a database or an entitlement engine tells it. It's either radius or PCRF, right, or diameter. And then I have some aggregation and routing functions. Well, the aggregation and routing functions on that end of the gateway could be completely reused between the two. And when I get down to the merchant silicon or the actual application of policies, I want to count the traffic that's going by. I want to be able to shape and meter and police. Those functions are common once again. It's really just those protocols, the fact that wireline has one tradition, one set of standards, and wireless has its tradition and its set of standards. It's the protocols out of the box that made them so different. So we believe strongly that disaggregation will enable a lot more reuse for a lot more components, both software and hardware. Virtualization, I don't think I need to sell virtualization. You guys all get that, right? That being able to slice and dice things and use them for different purposes in the same spot allows you to attack the bin packing problem that used to favor architectures that were highly centralized. Why would you centralize things and prefer a larger box? It's because if you have a greater number of endpoints served and you don't want to have leftover or fragmented resources, centralization helps with that. Now, if I were to move that single-use resource out to the edge of the network, I'd have fragmentation. I might have different amounts of workload in different locations and waste a lot of compute and other resources. However, if it's virtualized, if for example, my wireless and my wireline and my IoT and hopefully those other applications we talked about earlier, all the Rs, AR, VR, XR, whatnot, if those all use the same common infrastructure, my bin packing problem goes away. I have a common infrastructure that I can much more uniformly fill at the edge of the network with multiple workloads. And then cloudification and orchestration, those are really the tools that we use for reaggregating the components and making it a tenable, operatable ecosystem. Because once you've disaggregated something and made lots of little components, it's not going to get simpler. It's just gotten more complex in putting it back together and operating it and maintaining it. If you don't apply automation to the problem, it will sink you. If you apply automation to the problem, everything could turn out okay. All right. So, thank you. Okay. So, going now, and we got I think painted the picture that common infrastructure can support multiple different kinds of access workloads, and that the workloads themselves, through disaggregation, can be teased into reusable components. This is the thesis for convergence that I'm going to put forward. So in MAEC, multi-access edge cloud, and once again, this is an example, and I don't want to I think they do good work, but I'm not saying that they're the center of the universe. There's lots of other good work going on elsewhere as well. What you find is have the basis in things that people are making use of today. And of course, being AT&T, I'm going to peddle ONAP and Acrano. It's required. But not because I'm AT&T, but because I believe in it. I think that using the technologies being developed in cloud native is really where we should be looking, that there's a much greater pool of talent and input and innovation, and we don't have to invent everything as a telco community. We're not enough people anymore, not compared to the cloud infrastructure. And so trying to make our workloads work in spaces that are innovating and being brought forward, and then also, by the way, staffable by college graduates who didn't take a telecommunications major, is a really good thing at the end of the day. So what have we got here? We've got a substrate, a common infrastructure, a mobile access edge cloud. And it has a number of projects that I've listed here, most of them on the left from ONF, and most of them on the right from other places. So you heard earlier today that the Trellis project is like a fabric, and it's also sort of next-gen SDN. It helps interconnect things and create compositions. SEBA is the wireline access project at ONF. COMAC is the common core. So this notion that you might use the same core for wireless and wireline and other things is brought forward by COMAC. And then ORAN, separately, is developing software, open source software, to handle wireless access. And I've taken some liberties and drawn some circles, and actually I didn't do this, the good folks at ONF did, and identified places where we can reuse software microservices or underlying components. So I'm trying to show that this whole disaggregation and then making reuse is not just a hand-waving exercise, it's something we're actually practicing in the software communities that we're engaged with. And then off to the right, you see things that are not typically found today in these environments, the IoT, the XR, the CDN. These are the third-party applications that we foresee running on and creating business on these edge cloud installations. I don't know what they might be. I know they might want to make use of information from the ellipses on the left side, and in fact that might be a value add I can offer to third parties for those kinds of applications. Or they might be things that we get into as well, I just don't know. The picture though, I think paints a good one, that at the edge of the cloud, at the edge of our network, there is this common infrastructure. It's getting put in place by what I would call the common blocking and tackling, that the carriers still need to provide access, they still need to provide mobility and wireline to folks. And by creating a software architecture that allows us to run those things on this one infrastructure, we enable, well, basically we enable the business case that says, build that, not because they will come, but because you can use it for your own business. And then if they are to come later, on the right-hand side, third-party applications can make use of an already built and distributed architecture and system in order to do their thing too. Okay, so, but if AT&T is the only one doing this, it doesn't help anybody. Or if Bell is the only one doing this, it doesn't help anybody, right? That to be a vibrant ecosystem, especially to get that end goal of getting these third-party applications, there needs to be a kind of ubiquity, and maybe not totally, but there needs to be a good expectation that you can find this infrastructure at the edge of many networks. And so, yeah, I'm starting up high and then going down to the case for the chassis. At the highest level, you need to find that carriers are deploying in this kind of infrastructure, cloud infrastructure at the edge of their network, and building on it for their own use and for the use of others. And frankly, I don't know that we've gotten to the point yet where we've got public edge cloud infrastructure all skulled out. And there are definitely new capabilities that will need to come along with that. But to get started, there's this chassis thing that we had seen today, and I talked about at the beginning, that it's a start. Having multiple suppliers in this ecosystem means it's not just their chassis or his chassis, it's the community's chassis, and with multiple sleds being able to support lots of different kinds of applications, the chassis isn't limited to just a wireless or a wireline chassis or an edge cloud chassis. I'm hoping that you saw from the middle of the talk that this is all the same kind of infrastructure. And I would expect it would actually go beyond just communications, that, you know, for transportation and other types of near industrial application, that this kind of infrastructure would make a lot of sense. And then, you know, system integrators need to step up, that while a lot of times an OCP supplier is really good at churning out hundreds of thousands of items, they usually like to work on quarterly work orders with well-known, you know, projected units. And there needs to be, for people to innovate, they need to be able to buy one or two. And so there needs to be kind of a VAR chain. There needs to be some kind of a supply chain in the middle that goes from, I'm an ODM and I can sell you 100,000. Would you like one unit? To, you know, I'm your local VAR and I have some of these on the shelf. I can deliver one by the end of the week. So that kind of thing needs to happen. And then, like I said earlier, the community themselves have already started in the common rack management controller. There's still a lot of space in the BMC, the controllers on each individual item, and on the BIOS that goes into these things. And not to belabor the point, but a lot of attention and energy at OCP has been around trusted supply chain. We've had a couple of white papers that have been put forward on how do you deal with compromised equipment. And there are interesting technologies already in place. The web scale companies are busy working them out because of their embarrassing year last year. And what it means is that the system that you think of as a computer today is actually going to be a kind of a unified set of trust domains that need to come together and actually need to be purposely moved from the manufacturer to the VAR to the user to a post-user market, and that it's not the sort of, all these things have to be controlled and locked down to the owner and the person in charge, or the company in charge of the equipment. And then we can do other things to help with operations, like unify user interfaces, even down to things like lamps. There is an OCP spec for jumper cable colors. I don't know that anyone has paid much attention to it, but it is out there. And then most importantly though, and I've said this earlier, is that we really need people to sort of make their needs known, make their contributions come to this, and sort of not make it just one guy up here talking about what he thinks might be good for all of us, but everybody joining in and making sure that it's good for you and it's good for you, and it does the things that you need it to do, and it works in the use cases you want it to. This is open. It's not, I got a black box and I'm going to sell it to you. It's, can we work on this together? Is there a way that you can improve it? Is there a way you can improve it? This is how community works, and this is how we accelerate the path forward. So that's good for me. I'm ready for questions. Yes, there's a microphone coming.
So actually I have two questions. The first question regarding the ecosystem build-up, because you talk about the edge, the convergence.
Mm-hmm.
So my question is, what's your future plan to getting the relationship grows fast? Like ORAN, you talk about it, that's currently independent. And also AT&T also build up, work with Linux Foundation, build up the Oguz. So what's the relationship for the future plan among of those kind of organizations? This is one thing. The second thing is, when we talk about edge computing, so I believe we try to build up simple things to help our customer getting better experiences, no matter networking experiences or like application experiences. So looks like even though we used the open source idea to build up the chassis or some things, so what kind of use case you already have to verify those kind of open source things may really useful? Thank you.
Well, thank you too. If I don't remember, I hope you'll help me. So in the first case, I think your question was around how does it all fit together? What are our future plans? I don't know about the future plans, but we have current plans to make use of open source in many different environments. AT&T is extremely active in Linux Foundation. AT&T is foundational member of ONF. AT&T is extremely active in OCP. And I'm sure I'm forgetting a whole bunch of other, we have 300,000 employees, you know. So we can be pretty active in a couple of places. It is the important thing, and you know, all right, we're talking about open source, but I'm going to take one moment and say standardization isn't completely dead either. So we also have folks who are busy trying to create 3GPP standards or other types of enabling standards that are still important where they fit. So the plans are to bring all these things to bear, that each thing works at its own layer, that they, luckily, to the great extent, they don't overlap. If you look at the things that we're doing, they're pretty much complementary to one another. And we don't cover everything. I mean, we're not sending people to work on Linux kernels. There's smart people doing that, and they can help in that space. So, I don't know. I don't feel that I gave you a very good answer, but that's what I got. Now, the second part was about application use cases, if I remember correctly, and that what use cases do we have to enable, when I wasn't sure, enable edge deployments or enable working with open source and open specs? Deployments. That's easy. So the trick is, and I've tried to say this, I don't often say it well, I guess, that we believe if we take our own business and put it onto cloud infrastructure as cloud workloads, that makes the business case neutral. If we can do better that way at what we do today than what we're doing now, then it's all gravy. We don't have to count on extra low latency, I don't know what application, AR, VR, XR, or self-driving cars, or what have you, bots that delivers things to your front door. Those could happen, and they're only positive. That if the basis of what you're doing is to simply make the business you're already in and is stable and well-known, profitable with the new technology, then you're set to go. Okay, thank you. Wow, that was a long question.
Hey Tom, Jeff Sharp with AD-Link. On one of your slides, you were showing the ONF slides, the ONAP.
Yeah, do you want me to go back?
Slides with SEBA and all that. Quick question for you. I know we've been working together quite a bit on some of these. Names change on a daily basis. One used to be RCord and
yeah,
now
they do.
it's SEBA. But I guess the question is as we're providing gear and hardware and solutions into this environment, is there a plan to have a third party or an integrator to make sure that this is all putting together? Is that up to the AT&Ts and the Verizons and all that to integrate that together?
Right. So today, yes, that AT&T seeks and other carriers, as near as I can tell, all the ones I've worked with, and I worked with a bunch, are looking for system integrators and third parties to provide maintenance, support, training, go to when there's a bug or a security issue. They're not looking to make use of open source directly and become their own system integrator like you might see in a web scale company. It's really more that the open source helps with understanding how to innovate more quickly, avoiding vendor lock-in, and like I said earlier, something my management's really interested in is sort of focusing the industry not to solve common non-differentiating problems over and over and over again, right? That's where we think it makes a lot of sense. And I put the rest of the guys to sleep. Oh, was that great? I'm past time too. I forgot to hit the start button, so I still got 30 minutes.
Tom, you have a call out for, hey, join the community and contribute.
Yes.
But a lot of these projects, if people join, there's always a personal interest, right? Open source is great, but it's not a altruistic activity. It's a commercial venture we all work for.
Right.
How do you grow that? If it's only AT&T, your model of creating this standard model that developers can count on all over the place won't expand. How do you get other service providers and carriers to join, collaborate, and frankly not feel that you have, AT&T's got a huge commitment here. And that's fantastic, but in some ways it could be daunting to someone to join it because they're like, well, how do I influence that? They're already pushing so hard. Can you speak a little to your thoughts on how to grow the community from both the top line and all the way through?
Yeah. That's a good question, one I probably ought to think about before answering. But at the risk, it seems to me that you have to have a start. You got to start somewhere, and you guys are at least willing to listen to me. I don't know if other carriers coming up would carry as much weight. I realize that even though AT&T, we're at the bleeding edge, right? So we're kind of at the forefront, which means a lot of times we got to be prepared that what we suggested is not what will happen, right? eComp and OpenO became ONAP. And that same thing may happen again in other situations. We got to expect that, right? And the good thing about open source is that there's no good idea locked away behind a proprietary system. That if there was a crux of something really good, but the rest of the idea was crap, it can be salvaged and put into the next rev of a different project and see light in another way. So I'm still pretty positive that that's the right way forward. And I guess the only thing to do is to encourage folks to, I don't know how to get that done, but I'm trying. All right. Okay, so shall we, no, we should shift gears. At the break? Okay. He's going to help my question. And I'm going to pull up.
Tom, thanks. The way it would help your last question is to ask this one. Usually when you want to bring a group of people in, they all have to have a common goal. Let's talk really briefly, because I know we're trying to move forward, really briefly about shared infrastructure. And, when you look at the lens of shared infrastructure in this platform environment, just talk about that, and maybe that's a way forward.
Okay. Well, you're right on there that I think shared infrastructure is really important. It may be the case that not third-party apps, but other carrier apps will be the sort of first use of foreign workloads in this kind of infrastructure. Today, everybody's familiar with I hope so, with co-location. That's when, I've built a central office, and there doesn't need to be 3 in this block. So when the next carrier wants to come in and provide service, they can farm out or buy a section out of that central office and locate their equipment. Today, that's all interconnected at a very low level. But what if I had a central office that had infrastructure that everybody knew how to use? And instead of coming in and having to build out your own capital-intensive program, you could actually run your workload and then pay me for the infrastructure I've put there. That's kind of a win-win, right? Because I had another revenue stream for infrastructure I put into that central office, and you were able to provide service on top of that infrastructure. And of course, I'll probably be interested in doing the same things, right? And the early days of that's already happening. Most carriers are at least toe dipping with the big cloud providers for some of their workloads. And if this comes about, this common edge, I don't see why that wouldn't be a really capitally efficient and time to market efficient path to getting things done. You could see a lot more competition in a lot more places because you didn't have to be able to operate physical infrastructure in order to move in there. You could simply move in logically and orchestrate it from a distance. That could be a pretty big deal. Okay, so now, after having stolen all our time, at least I had already read you the introduction in the bio for Heather Kirksey. She's our next speaker and is going to come up and save me by talking about the virtual central office. Wow, haven't we just been talking about that?
All right, where's the clicker? So I will actually have a timer, but you know. So hey folks, so you know, kind of continuing on some of the themes we've been talking about. So it was kind of fun talking with you about Edge earlier, and then you know, we've been talking about the virtual central office, and what I'm here to talk to you about today is a sort of a proof of sort of ongoing proof of concepting that we have been doing with a variety of organizations, sort of really taking the open source software, the open source hardware, putting it together, and you know, sort of really validating as we go forward that you know, it's working. Are there things that we need to upstream? You know, are there things that we can think about in terms of how we're doing testing within various projects to support different use cases that we're doing? So, clicker does not. Do I need to? Where do I need to point the clicker?
One that does one on the right.
This one?
And hold it up, because PC's in the back. Maybe it's the one on the left after all. Try the left one. There.
Oh, there we go. Okay.
Just ask me, just say next slide.
Okay. Next slide, please. You know, I have to say, having been in the tech industry for 20 years and doing things like that, it's like sometimes you get to conferences and you're like, wow, what are we even doing attempting to virtualize all this infrastructure when we still can't make slide decks work sometime? But anyway, if you could advance to the next slide, please.
You should know when you want the next slide.
Yeah. So just a little bit, quickly, I think most people now are relatively familiar with the Linux Foundation, but we're definitely very, one of the early areas of growth within the Linux Foundation was the set of networking projects, to basically start, enabling all of these various industries, who depend on networking. And next slide, please. And so, we've all been watching this, this evolution over time. So, going from proprietary, back in the day, the vertically integrated monolithic things, I think, we're sort of beginning to get into, we've been doing that collaborative design and development. I think we're seeing that happen more and more. And then the idea, that it does change sort of the relationships in the ecosystem, and we've been sending those, huh? Okay. Oh, wait, maybe I got it. You skipped past some slides. Okay. So, just spent a couple moments, so last year, we created this new umbrella called LF Networking. I just wanted to pause for a moment and talk about that. We had a number of different networking projects within the LF. There's still other networking projects in the LF that are not part of this umbrella, but we did bring together FIDO, which works on VPP, which you heard Troy mention earlier this morning, Open Daylight, ONAP, OPNFV, Panda, which is an analytics platform, SNAS, which does BGP monitoring, and Tungsten Fabric, formerly known as Open Contrail. So one of the big fun things over the past year was sort of doing what amounts to a 7-organization M&A activity. But one of the things that's also been really useful is that we've been breaking down silos and really beginning to look at how we can collaborate across project and even outside of the boundaries of the LFN. And so, one of an early activity around this where before we even had LFN and working outside of those boundaries is, doing this cross-community open source collaboration. So the idea is we know that there are different pieces of the stack. So you were talking about, sort of things are disaggregated, the same way we develop in open source, it's not going to be one project that does every single piece of your stack. What that does mean is figuring out how they go together, how you want to, make sure that they're interoperable does desire some work. I also love the fact too that you were talking about, BNGs in one place and things that there are common functions. I was at a conference several years ago and someone was like, well, when do you know that NFV has, sort of accomplished its aim? And I said, I think is when we actually stop talking about things like VEPC and VBNG, and we just start talking about sort of functionalities and capabilities that are shared resources that different applications need. I don't think we're there yet, and in fact, you'll see VEPC in several of the slides I have coming up. But one of the things that was really cool is we decided that we wanted to build, a proof of concept, and I'll get to sort of the diagram of the pieces, but we were like, okay, let's actually collaborate across all these groups. So OpenFE, OpenStack, OCP, the Open Air interface, which is a fairly small open source project that's spun out of Etsy that's been working on some virtualized RAN software in an open source fashion, and Open Daylight. So we got the ball rolling by talking to those and got a bunch of ecosystem partners involved. So this is sort of in addition to the mainline development work that we're doing in all these projects. And so we had all of these companies sort of coming together and working on this as a proof of concept across all of these organizations. Which, when you think about it, sort of shows that actually this promise of open source is really valid and that it is working because people are really wanting to come together and collaborate in this environment and do so together. So I'm not actually going to spend much time on this slide because I think we just heard a lot about what VCO is from Tom. But one of the things that we really wanted to look at is as this virtualization and as this move to less telco style infra and more data center style infra, we want to I think we've talked about sort of the various values and benefits that come in here. And actually, beginning to look forward, right? We've started that process of virtualization. You heard from Troy this morning, as they're beginning to look at the edge, that they're really beginning to look at things like Kubernetes and going cloud native. So, we do see that as a future. And, what can we do in terms of looking at solving problems to solve that? This is actually from the Acrano project that you heard Acrano referenced in Tom's talk. So they're doing a lot of work on edge blueprints. And this really sort of gives a description too. It's a nice visual description of what we were talking about this morning in terms of the your core data center going out to your network edge and then over to the customer premises. There are different places along the edge where you're doing work. And where we focused this proof of concept was really sort of in kind of looking at 5G LTE and that kind of telecom network edge portion of it. So this has been an ongoing proof of concepting process. So at an OpenFE summit 2 years ago, we did our first one. It was VCO 1.0. We looked at both a residential and business use case. And what we did is we actually, from the stage in Beijing, we had actually built this stack with open source components as well as a mixture of open source and proprietary applications on top of that. And we actually sort of demonstrated those with live code, with live networking, connecting back and forth between the stage in Beijing and a lab in Raleigh, North Carolina. And so that was really cool, and we wanted to, kind of say, and you can sort of see the components there and how we architected it. So going into last year, we decided that we wanted to look at VCO 2.0. We once again sort of did this proof of concept live on a keynote stage with connection between Amsterdam and a lab back in San Jose, and it was all live running code, and we ended up showing a live phone call going back and forth between this network that we'd set up, which if you ever want to feel really nervous about a keynote presentation, do a live demo with live code, with connectivity, going under the ocean between two continents when 1,000 people are looking at you. And so we did it at 2 different summits, and in the second one, the fire alarm, which was a test, went off in the middle of trying to get all of this set up and explained. But the cool thing is it worked.
That's why they have that.
Yeah. So when we were heading into this proof of concept, we were looking at the requirements from the service providers. So we had service providers who were engaged with us in this proof of concept, being China Mobile and Bell being the sort of most engaged operators on this. And they were sort of giving this, okay, we want to think about our needs, so massive scale, the common deployment model for data, for the data center and CO locations, using OpenStack and/or Kubernetes, so those standard open source VIMs out there. We wanted to be able to show, that we are advancing ahead to 5G support, but they also do LTE, other things we're talking about, the centralized management and troubleshooting. So we ended up with this checklist of things that we wanted to do. So we had vRAN and CRAN for LTE. And then one of the things that we did that actually required upstream development in the OAI things was actually implementing the low layer and high layer split as defined by 3GPP in their 5G specs, so that we actually had that implemented live in upstream code. So I've been referring to this as a proof of concept, but the idea is that we didn't want to bring together a chain of things just specifically for a demo. It was more of a working exercise to figure out what we needed to do. So we actually, part of this was upstreaming all of that code into OAI so that the 3GPP specs were actually being implemented in the software. Another sort of upstreaming that came out of this is OPNFV now in our weekly test runs actually now will deploy an open source VEPC on top of our infrastructure to make sure that all of our NFVI builds that we do of the different flavors can actually support bringing that application up and it functioning. So one of the main philosophies that we had with this is that we really want, at the end of the day, these proofs of concepts to actually illustrate how you can build these networks with the out-of-the-box sort of open source components that are already there. We're not doing special tweaking. This isn't sort of, when you're doing slideware or pretend, kind of development, that we're really doing this mainline. And so it's going to be there in the code for people that want to do it. At the end, I'm going to have a point to our sort of resource center with this, but we actually did write a white paper describing the process of building this 2.0 demo, as well as a cookbook for actually being able to deploy it so you can do it yourself. So we wanted to kind of have low latent services. We wanted to demonstrate network slicing. We ran out of time, network slicing. We had some minor network slicing, but not kind of full network slicing functionality there. But we did have an LTE VEPC. We also wanted to get to VoLTE, but we didn't quite get there either. We used Ansible as orchestration. So what we would love to do, and I'll talk to you about our future plans, is actually showing ONAP orchestrating and managing this. That was another thing. ONAP was really kind of still, I think, in their first or second release when we did that. And we really thought trying to distract the ONAP community for this proof of concept was less important than having them get their first releases out as a community. So we just used some pretty basic Ansible-based orchestration. And then we showed some applications, both proprietary and open source applications on top of this, doing things like service assurance, monitoring, and we did have a mixture of containers and VMs. So this is what the stack pretty much looks like. So this is an OpenStack based infra that we did there. And so we got the NFVI from OpenStack. We used vanilla out-of-the-box SDN controller using OpenStack. We had white brick switch fabric that was provided by Mellanox. We used a mixture of OCP servers, and I'll get to sort of what those look like. And then we had the various applications that were doing EMS, and then we had several VNFs that we deployed on here. So as I said, the ONAP orchestration was still a bit aspirational at the time, but this is what we thought, a nice open source stack that supported sort of this mobile use case and was headed towards being 5G compliant look like. You can see sort of different people provided different things at those various areas of the stack. On the hardware side, because we were doing this in partnership with OCP, we had, once again, I think I mentioned we had a branch office that was on the stage, and then we had a main data center back in California. So we actually had a couple OCP members provide hardware both in the labs that we worked as well as for the on-stage. And you can see some more information. This is the chassis that we actually had going on stage. Once again, as I mentioned, we did have a fire alarm, and my first fear was that somehow the hardware had overheated, that we had not provided sufficient cooling and power to it. So all of these concerns, we actually worked through them. Obviously this wasn't sort of full real-world deployment, but we did run into having to think through the things that operators are going to need to. And then this switch was also the Edge core with Cumulus provided Linux. So this was sort of the architecture that we were going for. So this is very much coming from 3GPP. As I mentioned, this was sort of, we implemented the CUDU splits that 3GPP has decided are necessary for delivering 5G service. So it was really cool to have that there. And so this was sort of the network that we were emulating with the things. This was the physical topology with the lab, with our, basically we had a jump host for provisioning all of the servers. Then we had a software-defined radio connecting to some UEs. So one of the things that we did is, so all of the sort of main network pieces that we did were 5G ready, 5G compliant to 3GPP stacks. We couldn't find any experimental hardware that supports 5G yet, so it was still LTE going to the handset, but the network itself supports 5G. And as we're looking to the future, we've now got our greedy little paws on some actual proper 5G compliant UEs as well. So anyway, so we had a jump host that went to the internet, went down to the software-defined radio attached to the handsets, and then we had a leaf spine topology set up. It's not, there we go. And so then you can see, and this was sort of our actual physical demo topology with the Faraday cage, with the handsets back in San Jose, and you can see we have the software-defined radio heading to the RU and DU, and the CU, and then we had our our sort of software implementation of the mobile core infrastructure deployed on OpenStack, and then connected via VPN through the internet under the ocean to where we were on stage. So the process of putting together this proof of concept, as I said, our idea was not that we wanted to make something brand new. We wanted to demonstrate the way that the out-of-the-box open source software components and hardware components really could be built together to demonstrate this use case. We did find some things that we upstreamed. Also, OAI did build that, built the CUD split. But we had 15 organizations and more than 30 volunteers coordinating this proof of concept work. So, there's a lot of, is open source working? I think people don't really ask that anymore, but it really does show how people really can jump in and get involved. A lot of the folks who participated in this weren't, they were from different organizations. They weren't all members of the same organizations. They were from many different companies, and we were able, some people, they hadn't even been involved in any of these open source projects before, but they wanted to get involved. So this was a really great focused way for people who cared about this use case to jump in and actually, sort of accomplish something. One of the things we weren't sure with, bringing in the EPC and some of the new RAN software, we weren't really sure how that would work, would the interoperability work, but actually pulling it together from an integration perspective, it took us a couple months, but that also included the software development time. So in terms of getting time to market really sped up, it was a great sort of demonstration of that open source promise. Getting agreement on the specs and how we wanted to define the architecture was really helpful, and it was really helpful to have advice from service providers. And service providers serving very different markets. Bell and China Mobile were both very active in giving us their needs, and both of them, they're sort of happy with, that kind of what we built could be something that they started to look at being commercially viable. From a technical consideration, we had been planning to use OpenStack Pike. It ended up not having the capability, so going back to getting real-world experience of where the open software maybe had limitations, we found that we did need Queens to support the use cases. We also found that the machines, especially for the DU and VBBU functions, did need to be pretty performant. We did have a lot of fun going hat in hand to people for hardware for those, but we did, we found, we gained some knowledge on the specs, and we talked through that a little bit in the white paper as well. And sort of in our, working through this and doing the integration and testing things out, we did find that bare metal was the best option for RU. And then bare metals or containers for the DU, and we were using VMs for the CU function. So that was great, well and good. I think it demonstrates where we're going with the open source software, demonstrates that demonstrates that we're making progress. So then the question is, we're like, all right, let's try this again this year. This will be the third year in a row that we've done a proof of concepting around this. And what we really want to do this year, you were hearing earlier that a lot of people are looking at using Kubernetes and containerized pieces of OpenStack as they're looking more and more towards the edge. So what our rather ambitious goal for this year is to actually, first of all, now that we've got the 5G UEs, is to actually have a properly full end-to-end 5G compliant, from every single part of it, made with open source components, and we want to do it completely cloud native. So we are planning to build it up with Kubernetes. We are going to be working with all the application vendors and everything to make sure that those are containerized and cloud native. And the goal to actually see, all right, well, what do we uncover as we're trying to show a completely containerized and cloud native open source mobile network? What will we find that needs to get outsourced back into various projects and various communities? And what will we learn about any interoperability issues or problems with this along the way? We would really love to start collaborating with the organization Phil is going to talk about after me, which is the ORAN Alliance. Now that we have that ORAN as part of the Linux Foundation, we'd really like to sort of showcase their contribution to this. We'd also probably like to see VPP pulled in for this next stack, and so trying to get some folks from the FIDO community participating in that. And then we also would like to get the ONAP integration up and running so that we can show sort of an ONAP automated open source 5G network. So, and the great part is, there we go. We are underway with sort of doing this proof of concept. So you can see that first resources link. It takes you to the white paper I was mentioning before, which actually goes through the cookbook of how to actually deploy and build one of these yourselves if you wanted to start playing around in it in your lab, if you wanted to start putting your own applications on this type of infra. So we do have a cookbook in there. There's some other resources around this as well. You can watch the video of us having a call using the open source network. We played Islands in the Stream, which was great. It was great fun. And we are actively working on the third version of this proof of concept. Work plan is in place. This is the list to subscribe to. And there are various projects. I highlighted a couple of OP&FE projects that are working on this, but depending on where your area of interest is, there are a lot of great places to get involved and a lot of different projects you can work on, whether that is the ORAN project, whether it is looking at the mobile use cases in ONAP, whether it is learning more, getting involved in CNCF and various projects there that are trying to make, especially around, you were talking about this morning, the networking piece in Kubernetes, sort of be able to fulfill all these use cases. There are a lot of different ways to get involved, but I think one of the nice things about jumping into something like this is that it is very focusing, especially the question earlier, what if you're sort of new to these things, kind of getting involved in a very directed, use case driven proof of concept where different communities are participating together, gives you a lot of exposure. You can see the pieces getting involved, and so it's a great way for yourself if you're wanting to get more up to speed and really figure out a good place to jump and engage. This could be a great way to do it. And then, I also mentioned the OCP projects. I think Tom and Mike, were talking about some of the OCP specs that are supporting this type of architecture as well. So with that, I've got some time for questions if anyone has them.
Good job.
Yes, Troy. Yes, sometimes I'm not sure I need a microphone.
First off, thanks for being involved and pushing this forward. We've been working with OAI at Bell for some time, and shout out to Sayed Hashmi and Sarah Alcone on my team who've participated. And there's a couple things I want to mention, so more of just adding the questions. One was, you mentioned the whole 3GPP split, and we view this as a vehicle to actually challenge the vendor community to get more split options in 3GPP than currently exist. So it's not just about implementing what's there. It's open source. You can do whatever you want with it. You can twiddle with all the bits you want, and you can prove that this works and this is more optimal. So that's a huge thing. And whoever else is thinking about this, get your hands dirty and start to play with it. The other thing I wanted to mention as well was, gone on a slide here. Oh yes. So we actually are using it. So it's not just demo. Like, we're actually using it internally for training for our wireless to the home service. And unfortunately, they couldn't be here. Otherwise, maybe next time we'll do a talk on that. And we're looking at other use cases to leverage this open source stack to actually help us with our mobility needs. So.
Well, and I think that points to, once again, as I said, everything got upstream. This is all in the main line of the open source work. So, I mean, I'm talking about the proof of concept, but now the capabilities to do this and build it and use it internally are there, and you're not having to look for some, special sauce or anything from either yourself or any of your partners. Yes.
Thanks for the presentation. Your VCO 2.0 had stars next to slicing, and I'm just sort of curious, that's integrated in VCO 3.0 with... So the other things in VCO 3.0 are sort of our backlog of things that we didn't quite get to being able to make sure that we could do in the first one. So network slicing, and I forget the other one off the top of my head. I need to. And a sort of a follow-on, quick follow-on. The Open Area Interface Standard, is that also a Linux Foundation supported?
It is not part of the Linux Foundation. It's its own group. They're based in Sophia Antipolis, and they've been around for several years. They actually started working on this quite a while ago. Sort of a little bit of a thought experiment initially coming out of Etsy to see, could we start doing some of this in open source? And then we got in touch and started incorporating them into these VCO proofs of concept, and they've been great to work at. And I know that they are interested in sort of figuring out what their relationship with the kind of new ORAN group is as well. And Phil's going to talk about ORAN after me, so hold any ORAN specific questions maybe for him. Is that good? Yes.
Heather, first of all, thank you. I think it's pretty brave of you to do a live demo, and it's literally practicing what you preach, so it
Yeah.
worked, so that sounds fun.
If there's not risk, is it really that fun?
Exactly. Now, you had mentioned, and first of all, let me also tell you, second of all, let me tell you that I do have 100% the intent to read the white paper, but since we have the subject matter expert here, I do have a question on the
Yes.
on the DU portion. You had mentioned that there was some performance, at least one of the learnings, there was performance gains you can get from the DU and the VBBU. Do you remember off the top of your head some of the things that could have been done differently?
Honestly, I don't know that level of detail. I would probably want to defer to an engineering team unless, Troy, you have any insight since your team was working.
The DU and the VBBU, there was a statement on what things could have been done or looked at technically, and one of them was getting higher performance CPUs for the DU and the VBBU. Do you remember what the performance issues were there?
So actually, we were even using Intel NUCs, war boxes.
Oh.
So you can imagine performance too. So to scale that, we're actually looking at potentially using an offloading technology for that, whether it's a VGA,
So for those who didn't hear that, what Troy said was that. Sorry.
All right, well, we've got, by my clock, 30 seconds left. So let's take one last question, and then I will end on time. I have known Tom for a very long
Hello.
time. We actually used to do standardization together, so yeah.
Yeah, thank you for the wonderful presentation today. So I'm the Solutions Marketing Manager at Intel, and I develop solutions using Intel technologies. So my question to you is, from all projects from Linux Foundation, what would be the top 3 features you would recommend to us to include in the solution stack for considering the market demand?
3 features for Intel to implement in their products, or 3 areas to get involved with in
To get
open source?
involved with, in terms of the feature stack, if I consider the edge workload, for example, what would be the features which you would recommend for us to include?
Oh, I might try to defer that to Troy, maybe. I think for us right now, as we look ahead to this 3.0 demo, I think actually the work that we're going to do to figure out how to implement this in cloud native is probably going to have some feature sets fall out. And by fall out, I mean be illuminated that they're either missing or we don't know how to use them, and that we need to take those forward. So. I think as we get a little bit more in, that we'll see actually where there are some features missing. Is a little bit of what my expectation is. We are also in the, we've gotten past the what do we want to accomplish phase, and we're just now beginning to move into beginning of the implementation.
Thank you.
One thing we do need is more hardware. So if you are with a hardware company, hint, hint, and would like to participate, we are definitely looking for that, especially if we want to kind of have a whole, whole network deployed as well as ONAP deployed.
Yeah, we would love to have our reference architecture come in. Yeah, thank you.
So great. We'll get you some airtime next time I talk about one of these demos, and you'll give me some hardware. I love this. See, open source is great. It can even happen during a presentation. All right, cool. Thank you.
Thank you, Heather. All right, moving right along. Our next speaker is Phil Robb from the Linux Foundation. He's going to talk about ORAN, how open source software and standards will transform radio access. Now, Phil's experience spans more than 30 years working with leading edge of software and networking technologies, beginning with the launch of the personal computer. Wow, in the early 1980s. He began working with open source in 2001 at Hewlett-Packard, where he ultimately formed and led their open source program office to create and guide the open source strategy for process for the company. Today, as the Vice President of Operations and for Networking for the Linux Foundation, Phil uses his breadth of business, technical, and open source expertise to guide leading networking and telecom organizations to participate in and leverage open source projects to deliver rapid, disruptive, innovation to their customers at an unprecedented rate. That's a long sentence, man. So let's put our hands together. Thank you, Phil.
Poor Tom. That bio is supposed to be in the materials, but not read before I come up. That would have been my expectation.
So I hit start?
Please hit start.
Okay.
So, good afternoon, folks. Again, I'm here to talk about ORAN and its relationship as a standards organization, the ORAN Alliance, with a software community that's being started at the Linux Foundation. The relationship between open source development, community activities, and standards organizations has been evolving pretty rapidly over the last couple of years. At ONS, about a month ago, we had a panel where we were talking about how some of the hurdles in these organizations working with one another have been worked through over this time period. About a week ago or so, I think we announced a relationship with ETSI, the Linux Foundation with ETSI, where some of the standards bodies associated with ETSI NFV, MEC, ZSM, and so forth are actually actively working for and finding relationships with different open source projects that are hosted at the Linux Foundation. So that's one piece of that puzzle. We have been implementing ETSI NFV specs in particular inside of ONAP for the last year or so, as well as MEF protocols as well, as another example of open source and standards bodies working together. ZSM has just come to ONAP, interestingly enough, looking at what ONAP has actually already implemented with regard to zero-touch policy and reaction to analytics and telemetry data, and are actually looking to incorporate some of the things that are actually already implemented in ONAP into the ZSM spec because we were kind of predating it. So lots of different relationships between standards leading open source activity, sometimes open source leading standards activity. This relationship between the ORAN Alliance and the ORAN software community is a new kind of relationship, one that we haven't done before. So it's kind of new. We'll see how it goes. It too is very new in the sense that the ORAN Alliance was announced at Mobile World Congress earlier at the beginning of the year. And then again, just last month, we announced the ORAN software community that is working in conjunction with the ORAN Alliance to create some software components that are identified through ORAN Alliance. So what we see is the radio access network marketplace and ecosystem is evolving similar to what we've seen in other networking areas over the last several years. Namely, we're moving from an integrated vertical stack of proprietary solutions into something that is broken apart, disaggregated, with standards created between those disaggregated components, and then ultimately some of those components being very capable of being done inside of open source, where we can get lots of innovation, lots of folks looking at it with different use cases, get the network effect of those different use cases providing significant value. All right, again, we've kind of seen this transition from proprietary to the implementation of SDN to NFV to a full level of disaggregation, which I would say for switches in particular, that's kind of where we are. RAN is just now shifting from proprietary to a level of disaggregation and the creation of standards across those disaggregated parts. But RAN is a little bit different in that we have APIs that we can define, we have some code that we can put into open source, but we also have some implementation of intellectual property, particularly the closer you get to the hardware, that needs to be preserved, right? So, and this is one of the things that is consistent with standards bodies, is you're going to, particularly in where we're doing hardware, and that is where you're defining, what is really essential to be able to implement a standard, and then basically you provide, reasonable terms for licensing of that patent material for the rest of the ecosystem. So we have to find some way of still allowing for that to occur in the RAN space while also disaggregating and trying to create opportunities for multi-vendor innovation in different places of that stack. So ORAN, again, was announced at MWC with that goal in mind. And this is the ORAN Alliance, which is a standards organization. And they have 3 key principles where they want to lead the industry in those open interfaces. And most importantly, they want to put some kind of intelligence into that radio access network. Okay, so not only is it open, but it's smart. They want to specify those APIs and drive those standards where appropriate. They want to be able to put code into open source that implements some part of the stack where appropriate. And then they want to be able to leverage common off-the-shelf hardware as well as merchant silicon, again, as much as possible, recognizing that's not going to be always the case. So this is what the architecture looks like. And again, really those 2 main focus areas are create the open interfaces and have the ability to interject significant intelligence and strong intelligence and capability inside of this stack. So they envision it as an orchestration and automation top layer, something like ONAP, doing design, inventory, policy creation, configuration, and one of the key components of this architecture is, we saw it in an earlier slide from Tom, is this, this RAN intelligent controller, or the RIC. And that RIC is functionally broken into 2 different components. One that is not real time and one that is near real time. And the idea behind that is the not real time is really dealing with, again, the relationship of what that policy creation looks like, the ability to actually take output from artificial intelligence systems, machine learning systems, and identify overall meta type of relationships between those components across the various cell sites, and leverage that data and push it down into the near real-time environment. Whereas there's a near real-time RIC as well, and it's dealing more with the analytics that it can consume and immediate responses to those analytics in near real time down at the base station. And in this RIC is where we have the ability to create applications. They know of applications for doing things like radio connection management, mobility management, quality of service, interface management, or interference management, and so forth, with the expectation of other third-party applications being created there as well. From an interface standpoint, they've got the A1 interface between that orchestration layer and the near real-time RIC, the E2 interface spec between that near real-time RIC and the CU and the DU, F1 from the multi-rat down to the DU and so forth. So those are all working in one of 6 different work groups that are all part of the RAN Alliance, ORAN Alliance. And again, down at the lowest layer, within the radio unit, doing the physical and the RF, expectations that there's going to be proprietary levels of technology down there. So again, RIC is really kind of centered to this. It's where it's expected a lot of the open source contributions will be driven into. What it is really being able to provide area-wide data and controls for the UE, the cell, the DU, the CU, through layers 1, 2, 3. Being able to identify that user equipment and its location and predict its trajectory. Be able to identify the content, be it video, voice, or other, as well as then identify policies at the UE level, right, to control band, cell, bearer selection, as well as admin control and so forth. 2 main things that they want to get out of this is efficient resource usage, so optimizing the resource usage of the radio network, and the ability to provide new services, so particularly being able to slice things up so that you can identify different traffic needs for drones, connected cars, IoT, et cetera, and be able to manage that all through this RAN interface. So again, kind of breaking it down from where they see the functionality between the non-real time and the near real time, from the management domain down into the actual RIC controller. Use cases around policy enforcement, handover optimization, radio link management, advanced network optimization, load balancing, and slicing policy. Right, so again, this is a place where by doing this disaggregation, taking this away from just a simple vertical solution, lots of innovation can happen here at this level. We had one question earlier about the interrelationship between these projects. Well, certainly Acumos as an AI and ML engine will be something that is leveraged from ORAN. I mean, it's that, the data lakes created that are the expectation as to where that intelligence is going to come to being able to actually implement and modify and adjust the policies associated with the different cell sites to be able to manage that traffic in an optimal way. Similarly, there's an Acrano project where under the telco appliance blueprint, where ORAN is implemented inside of one of those edge cases inside of the Acrano project, so building that integration. So again, doing that network optimization, being able to manage and optimize for factory and industrial IoT, having a different type of environment for connected car and what you'd need to do there. Shipping and logistics, being able to lower the power on IoT devices as an example, and then rock solid security for handling of medical data. All different types of use cases, different types of requirements, being able to manage and both seen, recognized, and then policy created and managed for those different kinds of use cases. So that's the ORAN Alliance, okay? They are really identifying what those standards are, how that disaggregation of that RAN network looks like. Now as far as the open source piece. So like I said, we have these open APIs and standards. We have the need for having some level of open source software created and implemented within this stack. And then we have components that are really vendor-driven innovation, and we need to provide that ability for them, as well as being able to implement a reference implementation of all these components together. Right, so this is why this project is a bit unique. Because we have these open source components, this open source activity, and we directly have implementation of patent-bearing code that also needs to be part of this stack so that we can test it, integrate it, make sure that it actually all works. So the mission of this ORAN software community is to be able to manage that software development environment, store the code, build the tooling, have the developer integration testing all in one place. All right, so the project scope is everything from the development, testing, documentation, and so forth. We want to coordinate activities as well with these other communities, like ONAP, as you saw in another slide, and I mentioned Acrano as well. Acumos is going to be another one. Right, these will all be other projects that we'll want to interface with, particularly the open source development portions of this ORAN stack. From a licensing standpoint, we have two different licenses, right? Some of the code that's going to be part of this is under Apache, and that's all the open source code. There's another license that is not quite constructed yet, but very, very close to getting done. That's the ORAN specification license, and that's for the specification of code that is identified with, again, implementing essential patents from 3GPP and those that are created inside of ORAN as well. So that's the difference in that architecture. So from a community standpoint then, again, we want the ability for the open source community to operate as it normally does. And this is a breakdown of Linux Foundation and how these different structures are in relationship to one another. Again, we have project umbrellas. We've mentioned the Linux networking, Linux Foundation networking project. We have the deep learning project, which is where Acumos is. Underneath that, projects such as OPNFV, ONAP, Acumos, AngelML, and so forth. Again, ORAN and the ORAN software community will have a project like that. that will sit on that side. Its charter will be similar to all of the other open source projects done at Linux Foundation. And it will have components like the RIC, as well as OCU and ODU, and integration software as well. But again, now there's another side that will be in separate repositories and clearly identified as being under a different license than Apache, that is this ORAN specification license. Okay, so that way, the code is there, you can still look at the code, you can work with the code, but recognize that that code is going to be implementing patent-bearing royalties associated with it. Right, so in this way, we have the ability of developing all the code commonly with a clear recognition of what's under an Apache open source license and what's under a different license, but the ability to actually integrate that software and test it so that it's a full stack. Right, so for me, this is yet another evolution in how standards bodies and open source work together. Right, it is one of the things that has been difficult in different standards bodies and open source projects to work together is how do you work through the intellectual property regime. So this is a new method to attempt to get through that process. You know, the open source community portion will be like all other open source communities at Linux Foundation. Everybody is invited to participate. Again, the code is available under Apache. It will have merit-based project technical leaders, and again, a real just simple collaborative community, right? We'll see how the communities build with the other side, with the licenses where they're proprietary. That's part of the experiment to see how well that goes and what happens. But regardless, you know, even if it is a single organization that puts some piece of code out there to implement something, we have something that we can test that's real, right? And that's not going to be done a single closed door, but it can be done open and in the public, and it will go much faster, right? So that's the interesting part about the model. So again, really it's this ORAN Alliance and Linux Foundation community concept is new. The ORAN Alliance has been stated as something, one of the most influential things kicked off in 2018. We're looking forward to how the actual software community goes with that alliance. Recognize that there is a technical oversight committee that is part of the ecosystem for the ORAN software community. And the way we'll work this is as code is coming in to this common set of repositories or this common project, this technical oversight committee will identify it, will work with those that are contributing. Does it have anything that would be any kind of patent or royalty bearing? If so, then it goes into that one set of repositories. If not, then it goes into the other set of repositories for open source licensing. And so that way we have an oversight body that can be making sure that we're actually keeping that separation between those two different code bases. But again, ultimately as an integration project, be able to put everything together to be able to test it. I personally want to thank folks for some source material for this presentation, namely Arpit Jashpur from Linux Foundation, Hank Kafka and Oliver Spacek from AT&T. I started with this project as we kicked off the open source community portion of it, which happened again about a month ago. So from the ORAN Alliance standpoint, I'm still personally somewhat of a newbie. There are others in this room that I believe are involved, so as we answer questions here in a moment, we can get through that. For more information, again, ORAN Alliance website is there, as well as an ORAN Alliance white paper. Does a great job of kind of walking through what all the goals for the Alliance and the standards body is for. The ORAN software community is up and operating, and then like I had mentioned earlier, there's a Crano project in particular to implement the RIC inside of a stack for doing radio edge as part of the Crano telco blueprint family. And with that, I will take questions. Yes.
Hi, Phil. Thanks for the presentation. Richard Arthur with Fujitsu Network Communications. We've just been trying to follow all the evolution in the open source, and we're a bit confused by the SDNR that was in ONAP and the radio intelligent control, the intelligent controller that just seemed to come out. Does that replace the SDNR or is it augmented? Do we have any position on that, please?
The groups haven't talked yet, so I'm not sure how that's going to evolve.
Sorry, I have a question. Basically, I'm not sure whether when there's a software community founded, is there any timeline published? Also, as the focus was on 5G or LTE, but generally I see the open source community is lagging than the incumbent vendor, right? So like if you talk about OpenDU and OpenCU, the incumbent vendor already have the 5G ready product, right? However, the open source community is quite lagging. So taking the example of 5G deployment, how do you see this open source community software will evolve and could actually contribute to the, for example, 5G deployment?
Yeah, no, a very, very good question. And I need to iterate again the newness of this software community. In the sense that we don't even have all of the seed code from all of the organizations that want to provide seed code in those repositories yet, because it is really only about 4 weeks old. We will see what software gets contributed and where folks want to actually provide different components of that stack. My expectation is that most of them will be filled out, and again, in particular, we have a way of allowing that code to exist and still protect royalty-bearing types of environments and code that's going to be contributed. So that it should be breaking down a barrier to actually contribute that code into an open source ecosystem to create, again, a much more robust RAN than we would have possibly considered prior to an environment like this.
Hello. There are so many open source communities regarding the RAN, vRAN. So can you differentiate between your ORAN, Open vRAN, XRAN, those type of things?
That one is a great question, and as I said, I'm not that familiar with the ORAN Alliance and the various different organizations. Does somebody want to help me out with that question? Who's more?
So XRAN and CRAN combined to form ORAN, basically.
There we go.
I don't know where that is.
Yeah, and there's also Open RAN with TIP. That's where I was going to go next. Is it would be really great to have all these open source communities start to have a tighter collaboration. I look at OAI as an example, what Heather talked about earlier, and they've implemented essentially exactly the same model, different license name, but they have portion of their licensing that's Apache 2, and the other portion that's OAI licensed, which is patentable technology. And so I don't know if the ORAN SC is planning to do this as well, but to actually make it available royalty-free for research, educational, and non-commercial use, which I hope it is. Anyway, that's my first question. So
yeah, and I believe it is in the license. Okay. And one of the things that needs to be done that is often not done in environments like this is provide access and ability to work with the code directly, regardless of if you're a member of the standards body or not. And that's one thing that is essential for how we've structured this with the Linux Foundation. Again, that code that's sitting in the repositories at the Linux Foundation is accessible to anybody. It's not behind any firewall of any way.
Yep.
So it creates a more open environment.
Okay. So it'd be great if someone involved could start talking more to OAI and to OMAC and try to get them more aligned and potentially, merge, reuse, whatever. The other question I had was with respect to, I don't know if you could bring up the slide with the use cases again. Something occurred to me as you were going through that.
Can I get the deck back up?
Sorry, I asked the hard questions.
The deck back up?
So just as he's bringing that up, maybe there were a number of use cases that we were talking about AI and ML as an enabler, as enabling technology to help with the intelligence aspect of ORAN specification. And some of the use cases I thought were really ripe for a DLT blockchain technology, specifically say medical data security and so on. So anyway, I'm just wondering if you're aware or if anyone's thought of something other than AI ML, specifically DLT, as a way to solve those problems, because I think it would be a good fit.
Yeah, and we're very early on, right? So the RIC, as I understand it, a lot of the seed code from that is being contributed by AT&T. And then the rest of the community dogpiles on it and sees what they can do with it. Again, there's an expectation to be working closely with the deep learning project, with Acumos, with Angel, and so forth. But we're 2 technical oversight committees in, meetings in, is where we are, right? So wanted to provide the opportunity to, again, brief everybody on what this is and where we're trying to go. But yeah, we're in very early days.
Okay. Hi there. And I know you said you're very early on, so maybe it's too early for this question, but I'll ask it anyway. Is the OSC planning to define or create the full software stack for the ORAN Alliance, including the lo-fi, or is it just going to be certain layers that you'll be working on?
No, I think the intent is to be able to do everything, to do the full stack. That's why we've created a structure where we can have different licenses depending on the needs.
Excellent.
Thanks for sharing this. I'm very curious about the hybrid mechanism and the oversight committee and what the governance is around that. And you say it's early days. It would be probably the most important attribute of what you're describing. But it's sort of in a related context to that. How do new submissions projects get brought in? Let's just take as an example the use cases there. Mm-hmm. Are you guys trying to get, like a working group together to characterize use cases into functional requirements? How many folks are involved, if you will? That's really the question I'm asking.
How many folks are involved? And again, it's a great question. And again, a different model from what the Linux Foundation has done in the past, in the sense that, again, the ORAN Alliance wanted some place to be able to home some open source code. And they wanted to be able to do it and create a community that was typical of a good, solid, open source collaborative effort, right? And so they've come to the Linux Foundation to help us facilitate that. But unlike other projects at the Linux Foundation, it is the ORAN Alliance who has asked us to host this code for them and to create that ecosystem of developer best practices. But unlike other projects at the Linux Foundation, they're not seeking other membership, right? So there's no membership associated with this ORAN Alliance software community, or software community. It's actually ORAN Alliance that's overseeing, right, what's going in. All right, so this technical oversight committee is appointed currently from the steering committee of the ORAN Alliance, right? And there are 12 members that will sit on this. 6 of them have already been appointed. The other 6 have not yet been appointed. And they will be the ones that are determining which side this code goes in on. But as an open source best practice, I will be advising them that, as long as code is coming in and it doesn't hurt anybody else in the community, it should be accepted, right? Because that's one of the things that you do in an open source community. Very often, some contribution may be perceived as thoroughly worthless to 90% of the constituency. But 3 years later, you'll find it's tremendously valuable. I mean, I can cite example after example of this, right? But that's one of those open source best practices. And so we want all comers. And my expectation is, again, that the Technical Oversight Committee will have this code come in, again, as long as it's relevant and doesn't cause, again, significant burden. If it's just a pain in the butt to test and nobody's going to use it, you got to think, well, gee, do we want to add it or not? Right? So it's a common sense type of thing. But by and large, again, if somebody wants to contribute something, it's going to be taken. And that Technical Oversight Committee really needs to be there to figure out which side of that ecosystem do we put it on. Royalty bearing or patent implementing or not. Sure. No more? Jim.
I try to control myself. So I won't pretend to be a RAN expert to really understand the essential patents, but was there any discussion to say, look, get rid of all that proprietary code and let's go start greenfield square one design and do all of it in the open, so it's all truly open source code? Certainly the people that own those essential patents wouldn't like it,
But in the same ways, other open source projects are always disruptive or often disruptive. So was that discussed, and why wasn't that model pursued?
Tom, go ahead and start. And I'll
So
add in.
just open source code is not the problem. The standards are created with the acceptance of including essential patents. So the patent already exists. Company already has a patent on that. And if you wrote open source code, that's not a problem. They would still ask you to license their patent in order to use it. Right? So there's never been this
So is
issue.
the patent tied to the standard? I guess.
Yes.
Yes,
Yes.
that's what an essential patent
Okay,
is. It's
all
a,
right.
What an
you can't
essential-
implement the standard
the
without
standard has been
using
So
the
maybe
patent.
we need new standards then?
No, well, you
Well,
can.
but and this
Good
is
luck.
well, and this is, but this is, you know, maybe what you're describing might be a utopian down the road, but fact of the matter is, you know, organizations work hard in their research labs to come up with really innovative ways of doing things. And again, particularly the closer you get to the hardware, the harder that research is, right? And the less you're relying on the rest of the open source community, for example, to have a shoulder up on, right? So you do that work, and your reward for that work is, while you're coming up with a standard for the next really cool thing, is yes, you've invented something really innovative that the rest of the industry goes, yeah, that's a really good way to do it. We're going to do that.
Okay.
All right, and they implement that essential patent. That's a fact of our world, and it's one of the things that has been creating the friction between open source and not. We've been doing this inside of Linux forever, right? This is, Linus gets angry because the graphics guys, right, have proprietary hardware in their graphics boards, and they don't want to release those. So they don't do that in their drivers. They provide them as proprietary drivers and have the user install them to get around the GPL.
Yeah,
It's
I don't
been
think
going on
there's
for 2 decades.
Yeah, I don't think there's any royalties with those, though. That's the difference, I think, right? It's okay. I appreciate the education there. Will the royalty dollars be transparent to the world, or would they be privately negotiated by those who want to consume them?
It's as I understand it, it's always privately negotiated.
Okay. As an open source person, it's got an awful lot of smell of proprietary closed door. And I understand your explanation on some of it has to be, but then you go look at the oversight committee of, well, yeah, you can only join it if you don't come here where the community is, go there where the ORAN Alliance is and join them, and then only select people there will be allowed to be over here in that oversight committee. So there's just a few things that certainly, if you look at pretty much all the LF open source projects and other open source, OpenStack Foundation, et cetera, I'll politely call it a very unique model, and I will say there'll be an awful lot of open source purists who will have a very strong distaste for the approach. Understand there's reasons why.
Exactly.
I would strongly encourage, and I know you will as well, but I'll say this for the audience, encourage as much openness and transparency as is possible at all levels, including making those in the place of essential patents and others uncomfortable. Then maybe we'll get to the middle ground that everybody can get on board with going forward. Thank you.
Appreciate the statement, Jim, and don't necessarily disagree with it. And from my perspective, this is being able to disaggregate this stack and open up some of it versus none of it is really where we are. So it's a step. And for me, it's an experiment, right? We'll see how well this works. And if it doesn't work well, then it won't go anyplace. If it does, then we'll, exactly. So, but it's better, again, doing something in this case, in my opinion, is better than not doing anything. Yes?
Yeah, this is...
So we're 3 minutes
Yes,
past.
sir.
And
Yeah.
actually,
this is Ranga from HCL. A quick question. To implement the architecture that you have shown, there is a need to have some agreement with the RRU vendors, right? Because you have open front hall interface between RRU and the DU. Just like to know what is your thought process on bringing all these existing vendors on board for this specific architecture, or do you have any specific recommendation for the vendors to integrate those RRUs with the architecture that you had shown?
I think there's an open RRU interface in ORAN.
Yeah. For the
So it's
interface,
up
yes.
to vendors to decide to espouse it, obviously.
Yep. All right, I think we'll stop here. Thank you very much for your attention and the great questions, folks.
All right, thank you, Phil. So now I have the pleasure of introducing Saurav, who I've worked with for a number of years. He is, it says director, but I think you've been VP'd now, haven't you? He's been VP'd. And he is an engineering VP at ONF, and where he leads open source projects like Trellis, Volta, and RCord. I'm sure you've heard of them. He's been in networking and communications for over 15 years and worked on systems as diverse as network virtualization at Big Switch Networks, data center switches at Arista, and WDM optics at Inbalance. He was a part of the original team at Stanford that made SDN popular. Thank you, Saurav. And with maybe no further ado.
So thanks, Tom, for the introduction. Yeah, so if you look at the sheets on your seats, it says mobile backhaul SEBA, so it's a little bit misleading. I'm actually going to talk about SEBA first, and then talk about how it may or may not apply to various things in 5G backhaul and front haul. Okay, so a little bit about my outline. It's a little slow, but okay, so I'm going to talk about SEBA, and then a couple of components in SEBA that are critical. So one of them is Volta. I'm really struggling to move it forward.
I was having the same problem.
Yeah,
that's right.
Okay. So Volta and Trellis are two components, key components in SEBA, and then finally I'll talk about how SEBA can be applied to 5G. Okay, so to start things off,
So let him know it's going to stop.
sorry, it's going to be a little painful, just lots of animation, and if this is...
I've dropped you on this other desktop. I'm going to switch over this advancer. Give me 1 second.
Sure.
Any questions so far?
Go ahead and try to advance your slides now.
Okay. Okay, yeah, it's a lot more responsive. Thank you.
Is that you?
Yes,
Wonderful.
thank you. Okay, so jump right in. Now, CORD, we've been around for a few years now. CORD is the ONF's umbrella project. It stands for Central Office Re-architected at its data center. And it's been around for a few years, and the basic idea was that, okay, service providers have central offices. They have completely different hardware and software managing equipment that are meant for residential, for mobile, and enterprise customers. What if we could provide the same services, but again, off of the same infrastructure, this exact same infrastructure, to bring the economies of a data center, but also the agility of a cloud provider. And so CORD was built on the basis of the confluence of SDN, NFV, and cloud, taking the best aspects of those to put it together. So SEBA, which you'll hear about in a second, SEBA is built on top of CORD. So CORD, if you think about it, these are all of our projects, and the SEBA is one combination of those projects. And there was a question earlier in the day, okay, why is this not our CORD? Well, it is, and also it isn't. So there are aspects of this. We used to have a project earlier, we still do, called RCord, which stands for Residential Cord. And SEBA's architecture is similar to RCord, but there are a number of key differences. For a while, I used to call it the new RCord, and then we decided to go ahead with the name SEBA. Okay, so SEBA is built on CORD, and this is what it stands for, SDN-enabled broadband access. And the basic idea is the idea of a pod, okay? And so what's inside the pod? So it's really about fiber to the home. So fiber to the home networks, if you look at it, there's an OLT inside the pod, and then there are ONUs, and then an optical distribution network in between, which is typically a passive optical splitter. So for the OLT, we've gone with white boxes from the Open Compute project, right? Open accepted box, so this one shows EdgeCore's box. But that's a bare metal box, and each of those, it looks like a switch, but each of those ports that you see over there are actually the head end of a passive optical network. So each of those can support a PON, and the PON can have as many as 64 or 128 subscribers on it in the residential homes, okay? So you can have as many as 16 inside a pod, and then upstream, these OLTs connect to a top-of-rack switch, or two for redundancy. Okay, so this is a real switch. Also, this is OCP design, and the one we're showing over here is the EdgeCore 7712 with a Broadcom Tomahawk switch inside it, ASIC inside it. And then these switches connect to an external BNG. The BNG is external to the pod. And then locally, it also connects to up to 3 servers, which host all of our software, okay? So up until now, I've only shown you the hardware. There is an entire software stack that goes on top of it, okay? So Volta is an important piece, and I'll talk about that in a bit. But what Volta does is that it abstracts this passive optical network, the OLTs, the ONUs, the distribution nodes in between. The entire PON is abstracted as a switch to the SDN controller. So the SDN controller, the ONOS that you see over there, sees the PON as a switch, and it sees the real top-of-rack switches also as switches. So then you can implement a whole bunch of features on top of the SDN controller, which will work some for the PON, some for the top-of-rack, and so on, right? So that's the job of Volta and the SDN controller and the apps that get written on it. And then on top of that, there is another piece of software that we call the Network Edge Mediator. Now, the main job of the Network Edge Mediator is to work with the operator's backend systems, whether that's ONAP, whether that's a legacy OSS BSS system, but also orchestrate inside the pod, do the FCAPS work, which is very, very important for the service providers. So NEM is a collection of pieces of software that perform all of these functions. And speaking of the software, all of our software is containerized. So these are, they're all Docker containers. We use Kubernetes to run this. We install all of this with standard Helm charts. Okay, so all of this is very cloud native, and this is the change that had happened recently, about a year ago. We used to be based on OpenStack and VMs, and we made this move to Kubernetes and containers. So in a nutshell, this is what SEBA looks like. This is what a SEBA pod looks like. We did a first release of this earlier this year in January. A second release is coming out in the middle of the year, okay? And this is another view of how you can see SEBA is being built on top of Cord. At the very bottom, you have the Cord platform layer, okay? So there's things, there's Kafka as a messaging bus. There's XOS, which is a key component of that NEM that does the orchestration inside, and then the works with the operator backends on the outside the pod, ONOS being the SDN controller, and a whole bunch of logging and monitoring software, everything containerized, right? But after you install the platform, you can choose to install a profile, and SEBA is a profile that so what does the profile include? Okay, it includes a certain set of ONOS applications or XOS services that bring out all of those features that you need inside a SEBA pod, right? When Oz will talk about mobility, well, mobility is a different profile, and it might include a different set of applications and a different set of XOS services. So you can install multiple profiles on top of the same platform, okay? And then SEBA is about residential access or broadband access networks, so there is an access device control software as well, which in SEBA's case is Volta, right? And then on top of this, there is another layer that we call the workflow layer. So because AT&T wants something out of a SEBA pod, but Deutsche Telekom may want something completely, not completely different, but significantly different, okay? And Turk Telekom may want yet another aspect. So as an example, AT&T wants to do authentication using 802.1x. Okay, but Deutsche Telekom and Turk Telekom want PPPoE. So that's a significant enough difference so that you, in a particular deployment, can deploy an AT&T workflow, but you can take the same components and take it in a different place and deploy the Turk Telekom workflow. Okay, it's the job of the workflow to ensure that the apps that are brought up, the services that are brought up, the configuration of those services are different depending on the operator's needs in that particular deployment. Okay. So a SEBA community started off with AT&T and ONF and a lot of hardware and software that comes from the open compute, but also we couldn't really do this without this set of people who have worked together to build the first version of Volta and SEBA and ongoing collaborations into the second and future versions of it. Okay, so very quickly I'm going to jump into Volta now and tell you what exactly Volta does. And it's going to be important even down the road when I start talking about mobility things. I'll sort of try and correlate the two. But the idea behind this is that traditionally an OLT used to be a big chassis-based box, right? So there's many functions over there. There's the PON actual MAC that does the optical stuff over the PON. There's compute plates where the software gets written. There's services that get implemented inside the box. There's a backplane that connects all of these together. And there's probably an EMS that controls this box, right? But when we SDNize it, the idea behind it is that you could just take the PON MAC plates and have them as little pizza-sized boxes, which has the PON ports that support the PONs, but then write the software outside the box. So Volta in this particular case is software that is written outside the box, that manages the box and presents an abstraction of the PON to the SDN controller so you can write all of the apps on top of it, okay? So that's the job that's the main work of Volta, and in this work, we also brought out the industry's first white box OLT. What we call white box is basically open hardware specs that you get, say, from the OCP. So this is an AT&T submitted spec for XGS PON. There's another one from Deutsche Telekom for GPON. But open specs that get accepted in the OCP, and then open source software that is written by ONF as well as OCP. So ONL and ONI we get from OCP. There is a chip driver piece that is not open source, but supports open APIs. That comes from Broadcom in this particular case. And then everything above that, the OpenOLT, driver, Volta, all of that is open source, Apache-based, comes from ONF. Okay. So very quickly about that abstraction. So this is Volta reaching out to the physical OLT and saying, hey, hello, can you tell me more about yourself? When the OLT tells you more about itself, it creates that logical switch abstraction, right? So you can see the ports on one side reflecting the NNI ports of the OLT. And then when ONUs get discovered, more ports come up, this time representing the uni ports on the ONU. So what's going on is that what you're losing is the network in between. So that's sort of hidden from the SDN controller. SDN controller sees Ethernet in on one side and Ethernet out on the other side. And the PON level details, the OMCI messaging, the PLOM stuff, everything that goes into managing a PON is actually taken care of by Volta. So the SDN controller can write the apps with that logical switch abstraction, just like it writes app for a physical switch abstraction, okay? So this is kind of important because I'll come back to this towards the end of my talk. So Volta, now I'm going to switch a little bit and talk about these OLTs when they connect upstream to the top-of-rack switches, right? The top-of-rack switches are also SDN controlled. They're also based on open hardware specs and open source software. And in a SEBA pod, you will typically see one or two of these switches, but it can actually be extended to an entire leaf-spine fabric. So that's what Trellis is. Trellis is a leaf-spine fabric that can have compute or access devices connected to it, and also upstream routers. You can even stretch Trellis from a sort of central office to maybe something that even goes closer to the end user. Say we call it a field office, but in the cable world, you can call this a primary head end and a secondary head end. And so this whole thing is, again, SDN controlled with a set of applications written on top of the SDN controller ONOS. And Trellis is also in production trials at Comcast. So there is, again, another community built around Comcast and ONF and OCP that has been working on Trellis for the last 3 years. And now it's very heartening to see that it's in production trials. So again, like I said, we call white box being open hardware specs from the OCP and say open source software that comes from both ONF and OCP. So very similar to what you saw for the OLT, we've done the same thing for top-of-rack switching, okay? And moving on, there's one piece that I was talking about if you look at the software on the right-hand side, again, what is not open source but does support open APIs is this software that comes from Broadcom. In this particular case, it's OFTPA. Very similar to Volta. Remember how I was saying Volta presents an abstraction for the PON, makes the entire PON look like a switch, a logical switch. Similarly, what is software from Broadcom called OFTPA that gives you an abstraction of the pipeline inside the switch. So under the hood, there may be different ASICs with very different pipelines, but they present an abstraction of one pipeline, and you can use that from the SDN controller to program it and bring out several different features, okay? But what we have done is we have added to Trellis, okay? So what you can see over here, that there's Broadcom Qumran, Tomahawk, Trident 2 switches, and they all support the same abstraction, which is OFTPA, so you can write a number of different applications on top of ONOS. But this is an abstraction that is a fixed function abstraction, right? So you can't change this. If Broadcom says that this is the L3 routing table, or this is the MPLS table, or this is the bridging table, that's what they are, and that's what they do, and that's what their sizes are, okay? But recently what has happened is that there are more, how shall I get it, programmable pipeline hardware that has come out, so you can determine what the pipeline of that switch should be. And we use the P4 programming language on this newer hardware, which we can define the pipeline inside the switch. And what that does is that not only can you do the things that we traditionally do in Trellis, but you can add more features because you can define what the pipeline is. So in this particular work, what we have done is that we've taken and added SP Gateway U functionality in, so, you know, NCAP, DCAP of GTP tunnels, and implemented that inside this newer hardware, together with the rest of the things that we had before. So we, and this was a demonstration that we had done at MWC last year. So it's basically Trellis, but it has newer functionality that can be done in hardware because we've used programmable pipelines. Okay, so that now brings me to how SEBA and 5G can sort of work together, okay? So this is the same picture that I was showing you, 2 slides back. So what you have here is the 3GPP core control plane, right? On the left is the RAN. Okay, that's as before. There's backhaul that's taking you to the central office. In the central office, you have the core network, the 3GPP core, the EPC. But one functionality of the EPC, which is the S gateway and P gateway user plane, has been taken out of servers or containers running in the compute nodes and implemented directly to the hardware, top of rack switching, okay? So that's what Trellis is, and Trellis enhanced with P4 gives you this capability of doing these newer functions in the hardware, okay, at line rate. Now, let's look a little bit further. We know in 5G, well, in 4G at least, if you look at the RAN stack, and maybe I'm just preaching to the choir and you already know all this, but if you look at the RAN stack, there's a lot of different functions over there, starting from where the radio is on the right-hand side. You go through the PHY, the MAC, the RLC, the DCP, and then you go towards the EPC. So that's what 4G was. All of that RAN stack, you can say, was the BBU, and the BBU is located at the base station together with the actual remote radio head, right? So the functionality to take the remote radio head and the BBU and communicate back to the EPC in the central office, well, that was what we naturally call backhaul, right? So something that you saw in the previous slide. But if you take it one step further, in 5G, that functionality has been broken up. Now there is a RU, there is a DU, and there is a CU, and there are various options in where things can get split, right? So now one way to think about it is the high split, where the DU and the RU are still at the base station, okay? But the CU has moved closer to the EPC back in the central office. So that high split, which is option number 2, or the F1 interface, as you call it, this is something that we have demonstrated recently. So Oz will definitely tell you more about this in his talk, but at Barcelona earlier this year, we had the option 2, the F1 interface with the DU and the RU at the base station, but the CU next to the OMEC, which Christian talked about earlier in the morning, the EPC core with the CU at the central office. All of that connected through Trellis, but the same infrastructure also supporting a PON, right? So you see the OLTs and the ONU and the residential subscribers both connecting to Trellis. The RAN DU connecting to Trellis as well as the ONT connecting to Trellis, okay? So this is the way to think about, different kinds of access but connecting to the same infrastructure. Now there was a lot more that was shown in this MWC demo, which I haven't shown in this picture, so Oz will tell you more about it. But I want to take this further and suggest what might come next. Because this is the high split, and if you know, the high split is very similar to backhaul, doesn't have, it has high bandwidth requirements and low latency requirements, but it's not as stringent as the low split, right? Or the various kinds of lower splits. So this is still doable. So instead of imagining that the base station is connected by fiber directly to the central office, you could, for example, imagine that the base station goes through a PON and connects to the central office. So you see the difference between this picture, where that's fiber connecting it to the base station, whereas this time it's going through a PON, right? You won't typically use the same PON for both residential subscribers and mobile subscribers, but you can certainly use different PONs for different kinds of subscribers, right? So this is something that we will be working on next. And then I'm going to look at something more futuristic, which is right now, as I was saying, the low split has many, many different options, and then the bandwidth and latency requirements become much more stringent. And then doing these things over a PON as front haul, or the front haul 2, or the FX interface becomes much, much harder, right? So there are people who are working on it, who are the PON experts, so from ORAN, the mobile experts from ORAN and the PON experts from ITUT, they are working together on it. And they are saying that, okay, if we had to do this front haul, but take it over a PON, then there is a need for the DU to be talking to the OLT, because the DU does the scheduling for the mobile side, and the OLT does the scheduling for the PON, and there needs to be some collaborative dynamic bandwidth allocation in the PON to handle the stringent latency and bandwidth requirements. Okay, but this work is still a few years away to get done, and then the hardware to be available, so low split over a PON is not something that we're looking at today. Okay, high split, just fine, low split, a few years down the road. What is a lot closer, actually, is millimeter wave, okay? So this is something that comes courtesy of Deutsche Telekom and Facebook. So Facebook has a project called Teragraph, okay? And that's millimeter wave. Now there are two different spectra that you can work at, carrier frequencies that you can work at. One is the 25 gigahertz one, which is licensed. Then there is the 60 gigahertz one, which is unlicensed. So Facebook's Teragraph works in this unlicensed 60 gigahertz space. And the basic idea is that you have these point-to-point connections between, in a dense metro area, you can use 60 gigahertz, and you can backhaul things, like small cells, or wireless to the business, or wireless to the home even, okay? And at some point, this needs to go into the wired infrastructure, which is what you see up there with the red fiber going into the provider network. So we are currently under discussions of how we can take Teragraph and include that into SEBA. So what you see over here, and I was threatening that I would come back to that PON, that abstraction of the PON as a pseudo Ethernet switch to the SDN controller. Well, that abstraction can go beyond the PON. So the idea is Volta today takes the OLT and the ONU, just ports on the OLT and ONU and abstracts that as a logical switch to the SDN controller. Now imagine that instead of the ONU, you have a box that sits for wireless to the home, and instead of the OLT, you have another thing that does Teragraph termination, okay? And in between, instead of the optical distribution node, you have the Teragraph millimeter wave network, okay? So to Volta, it can extend that abstraction to the SDN controller, so the SDN controller really just doesn't see or manage the Teragraph network, it just sees the ports on either side and does what it does, what it's meant to do, okay? So this is still under discussion with both Facebook and Deutsche Telekom, but this is something that we can look at. It's just different kind of 5G. Instead of the cellular technologies, it's the millimeter wave technologies. Okay, to summarize then, ONF, as I said before, and also Christian had said earlier today, CORD is our flagship umbrella project. SEBA, or SDN-enabled broadband access, is a profile that is built on top of the CORD platform. It's built out of modular components. I only mentioned 2 today. There are more, but Volta abstracts the PON. Trellis manages a leaf-spine fabric, a multi-purpose leaf-spine fabric. And when you think about SEBA and with 5G, we have done some demonstrations at MWC Barcelona a couple of years ago, where we did the SP gateway in hardware in Trellis, and more recently, SEBA together with OMEC that you heard about this morning from Christian, and then a high-split RAN. That's one we have done, and actually much more that Oz will tell you about. And the low-split RAN is something that really realistic is probably a few years away before the standards are done, and to do that over PON. The standards are done, and then the hardware is available in the market. But Teragraph and millimeter wave backhaul and its combination with SEBA is a lot more realistic, a lot more near term. So just a quick, I've talked about a few of our projects today, SEBA and Trellis and Volta, but really ONF has a whole bunch of other projects. And if you're interested, please do check us out at opennetworking.org. And here's a few other links about how to get involved with some of the things that I've talked about today. Thank you.
Thank you. I think you've got a few minutes for Q&A. Yeah.
A few minutes for Q&A if any quick questions.
Until the red light is on.
Yes.
I hope this doesn't seem like too basic a question, but back when you were talking about white box OLT,
yeah,
what kind of optics would plug into that to be used as an OLT in a white box?
Yeah, there's there are transceivers XF.
Yeah, it's XF transceiver that's unique to PON. It basically sends and receives on different frequencies on a single fiber.
But would this be the same kind of OLT pluggable that's available?
Yes, that goes into the existing
so
commercial products.
All right. So it's really an OLT pluggable that's going into the white box.
No, there's
it's a laser only. It's only the optics, not the OLT MAC machine.
Are these widely available?
Yes, they are. So if you look at the third link under the SEBA, it's called, there's a BOM over there, and we specify exactly the XFPs that you need to buy. I think one of them is from Ligent, and the other one is from Source Photonics. And you shouldn't confuse this with a product out of a startup called Tibit, where the OLT itself is on the XFP.
That's what I was talking about.
That you can plug into a regular switch.
And I was confused, but I'm not now.
So there's two different kinds. There's the OLT pizza box, which has all these ports where you just put in a transceiver. And then there is an OLT on a transceiver that you can plug into a switch.
Right.
We're actually working with Tibit and Delta to bring that into SEBA as well. It's not there currently, but it should be soon.
Thank you.
Yeah.
There's another question in the back. Is it Raz?
Hi, I got a question regarding Trellis. Is Trellis also functioning as a NOS for the white box switch? Or is the plan to use something like Danos for that?
No, so it is, so we won't. It's not compatible with Danos. So the way to think about it is that Trellis itself is the network operating system, but it does not sit inside the box. What we have running inside the box is Open Network Linux, right? And some software that comes from Broadcom, which is OFTPA. But in itself, the software that runs inside the box will not do anything, right? Now, Danos, on the other hand, runs inside the box and brings out all the features, right? But this is Trellis is the SDN way of doing things, where the box itself won't be doing things. All the intelligence is outside the box, and it manages this. So Trellis, as the software, manages not just one box, but a whole collection of boxes in a certain topology. So it's very different models.
But wouldn't you be interested in moving to a more dynamic way where the NOS can be provisioned and sitting on the box itself?
I think if somebody else wants to do that, they are welcome to do it. We have gone down the path of doing this pure SDN model. We have put it into production at a tier 1 operator, and we expect to continue working down this path.
Okay, thanks.
Yes, question? Red light's on.
Yeah. Red light's on.
Okay. So maybe in the open, or maybe if it's quick, yeah.
Thank you very much. Very interesting presentation. So among the non-ideal front hauls, you showed PON and millimeter wave. Was there other non-ideal front hauls like DOCSIS cable network, for instance, that you considered?
So I had a little bit difficulty understanding your question, but you're saying,
So,
does SEBA apply to other, like
DOCSIS.
cable networks or
Yeah.
DOCSIS?
Yeah.
It could. There are some people who are talking about it, especially KPN out of Europe. There has to be some work that has to be done inside Volta to maintain the same abstraction for DOCSIS or DPoE, as it's called. It's not today, but there is no technical reason why it cannot be so. So there are people interested in it, and if we find enough community behind it that's willing to implement that, we'll be welcoming that in SEBA and Volta.
Thank you.
Thank you.
Okay, thank you.
Thank you.
And on that bombshell. I really don't know what that was, but it was scary. All right, so our next speaker is Sunay. He's also from the Open Networking Foundation, where he is the chief architect for mobile networking. And he is, he leads servers provider-driven mobile edge cloud platform built on the pillars of open source, SDN, NFV, and cloud, aiming to drive the transformation of wireless network infrastructure and business models on the path toward 5G. In this capacity, he manages open source projects OMEC, which you heard about earlier from Christian, and COMAC, which I think you're about to hear about right now, and oversees multiple company proof of concept developments. Prior, Dr. Sunay was the chief CTO at Netsia, where he was the innovator of a programmable radio access network architecture program for 5G that enabled the world's first dynamically programmable RAN slicing solution. He also held prior positions at Nokia Research Center and Bell Labs, as well as academia. Dr. Sunay holds over 40 US and European patents on various aspects of 3, 4, and 5, any 6G? Okay, and I'm sure that'll come. So let's welcome Oz.
Thanks for sticking around. This is the last presentation before our town hall Q&A. So I thought, I sort of anticipated after I realized that this was the last talk, what the prior presentations would be. So while introducing COMAC, I'm going to try to summarize what has been talked about. So you'll hear bits and pieces of what Tom talked about, what Saurav talked about, Christian, Phil, Heather, will all be part of this.
Everybody has to go through it. So.
Yeah.
What's that?
Oh, that's the laser pointer. You gotta use the
Just
arrow.
arrows, right? But it's not working. I can't get this to work. Oh, here we go. All right, thank you. All right, so I'm going to introduce to you a brand new project at ONF called COMAC. COMAC stands for Converged Multi-Access and Core. So at the center of all this is convergence. So to make the case for COMAC, first let's talk about the scope. The whole idea of COMAC is, as a project, is to create a modular, cost-effective platform and components with well-specified interfaces for access and core. And within that, we have OMEC, which is our open source 3GPP core. And then a converged user plane function that converges all potential user plane functions that you would find at a operator edge. So that would be the user plane of the BNG, the user plane of the core network, as well as the user plane of the disaggregated virtualized component of the RAN. And then the associated control plane functions, and the intelligence-bearing controllers that map the different control plane functions with this converged user plane. So that is sort of the scope of the project. And as with any other project within ONF, we have a bunch of operators backing this with the intent of taking the outcome to field trials and potentially to deployments. And in our case, this is a wide group. We have AT&T, Deutsche Telekom, China Unicom, Google, Turk Telecom, and Sprint, who are committed to taking all or components of COMAC to field trials. All right, so let's actually take a step back from COMAC and revisit the edge cloud conversation that we had earlier on. So that will hopefully give us a case of why within COMAC we're talking about multi-access and why we're really attempting on convergence. So today's telco operator networks looks something like this. So a telco that provides subscribers connectivity services via different access technologies. If one of those access technologies is cellular, we'll have a wide deployment of base stations and its aggregation towards a centralized location where core network components in a vertically integrated way would reside. And similarly, for broadband access, at homes you would have CPEs and ONUs aggregated at OLTs, taking you to, again, telco central offices where you would have BNGs. And then you would have applications that telcos provide, there are also a lot of applications in public cloud that as end users we consume. But towards transformation of telcos, as Tom mentioned, the first thing for AT&T, this was AIC, was virtualizing and cloudifying the central cloud, central locations of the telco network. So in that light, virtualization is taking place. So some operators are way ahead and some are just starting, but virtualization is the key word right now. So in that light, for the cellular network, the core network itself is being virtualized, it's being disaggregated, the user plane, control plane is being separated, and on the broadband side, we have virtualized BNG solutions as well. So the next step for that is going to be the edge. And the edge itself is really a real estate, which is very, very close to the end users. And it is there for a variety of reasons. We heard early on that latency, higher bandwidth, and transport efficiency are all reasons. Another reason potentially is traffic localization for whatever reason. Enterprises may want to localize their traffic and not necessarily have it go out in a selective way. So in either case, we have a need for an edge. And one of the first benefits of the edge is that it brings us an environment which enables us to distribute the RAN. Following ORAN principles, we can distribute RAN into three distinct components. The RU, which would be at the antenna sites, the DU, which would be at the cell sites, and the CU, which would be at the edge cloud, pooling multiple RUs and DUs. And if we want traffic localization or low latency, the next thing that needs to happen is the user plane function of the core network needs to be pushed to the edge so that we can start talking about local breakouts. And once that's there, its counterpart at the broadband side would be moving the BNG to the edge. But also for low latency applications, then the local breakouts would actually be connected to these low latency or high bandwidth requiring applications. So that means those applications will, or components at least of those applications will be needed at the edge as well. And we also heard about the potential at some stage turning this into a multi-tenant environment. So if that is the case, some of the OTT applications might be actually located there as well. So when you look at the big edge cloud picture like this holistically, one thing that you should pay attention is this is an environment for an operator where multiple access technologies are being terminated. And this is also an environment which actually hosts core network components of these distinct access technologies all in the same location. So COMAC is all about actually dealing with this and how we can talk about convergence with this big picture in mind. So convergence has been around for a very long time. In fact, Fixed Mobile Convergence Alliance was formed in 2004, and it was disbanded in 2010. So we have been, as industry, talking about converging the cellular and broadband access for a very long time. But it is relevant now. It is relevant because now we have virtualization taking place at a very, very rapid speed. And we have CUPS, the control plane, user plane separation, allowing us to treat this convergence at various degrees on the user plane and on the control plane. And we have functional disaggregation, all the way going towards microservices architecture, where rather than talking about appliances, we can start talking about functions, and these functions, the commonalities in these functions can be converged together. And the last but not least pillar is the edge itself, the edge cloud, where a lot of these functions will need to be co-hosted. So on that light, COMAC actually talks about convergence of three distinct components. One is the 3GPP core. So as you have seen, especially the user plane function of the core will most likely be hosted at the edge. And likewise, in the same location, the disaggregated RAN virtualized component will also be hosted. And we would also have, at the same edge location, the broadband access BNG. So COMAC is about converging these three distinct access technologies, the RAN and the core of 3GPP, and the BNG of the broadband access. We will follow a phased approach in this. So as all right, so as we heard from Christian early on, OMEC, our open source EPC, is going to be our first phase. And this is actually going into field trials this year with T-Mobile Poland, taking it to field sometime this summer, and probably in fall or winter of 2019, we'll have Sprint taking it to field trials as well. The next phase would be the enablement of coexistence over a common edge cloud platform. And then we will start talking about a user plane convergence. And the last piece of the puzzle would be convergence of the control plane, leading us to the COMAC platform. So to be able to get there, we have to first talk about disaggregation. So let's do that. So from a cellular perspective, we all know what access and core is. From a broadband access perspective, you can treat the BNG to be the core network of the broadband access. And the CPE, the ONU, and the OLT could be the access portion. So with this terminology, let's talk about the disaggregation. On the RAN side, again following ORAN, we have an RU-DU-CU split. And again, starting from release 13 of 3GPP, we can have a user plane, control plane separation of the core network. And if you want to go into the details, again using LTE terminology, you would have the MME, the gateway control plane, PCRF and HSS collectively forming the control plane, and the gateway user plane making up for the core user plane. And then actually the next phase would be the further disaggregation of the virtualized component of the RAN into user plane and control plane. On the broadband side, we can follow a similar disaggregation. We can disaggregate the BNG into user plane and control plane, realizing the individual functional components in the control plane, being address management, subscription management, the authentication, the AAA services control, etc. So with that, we can now also integrate this with programmatic access. So early on, we heard about RIC from ORAN. We heard about Volta with its corresponding ONOS controller for broadband access. So this clearly needs integration with that. So again, following up on what Saurav just showed you with, on the broadband side, we would have ONOS with a specific virtualized OLT application controlling through Volta the broadband access. On the cellular side, again, following on the ORAN specs, we would have, sorry for this. Yes.
We're getting you another one here, sir.
Okay, thank you. So I'll tell you when to move. So on the ORAN side, we would have RIC effectively controlling, wonderful, thank you, controlling the DU and both the user plane and the control plane of the CU. No, this is not working either. So let me ask you to just move, yeah. So now that we have talked about disaggregation and then integration with programmatic control of access, let's first talk about the enablement of coexistence. Next slide, please. So coexistence means we have all these components at the edge, and they are to share the same hardware infrastructure, and they are to share the same cloud orchestration, SDN control, and the services control stack. So with that, the fabric and the trellis is going to be shared across both broadband access and cellular access. And we would also have the same cloud orchestration platform managing the elasticity and the scaling of the individual containers that make up both the broadband and the cellular access. All right, so now that we have this, the next phase would be the reaggregation or the convergence. So the first phase would be the convergence of the user plane. So we have three distinct user plane functions at the edge. The user plane of the CU, the user plane of the gateway, and the user plane of the BNG. So at this phase, COMAC project would be all about converging these user plane functions. But depending on which packet this converged user plane function is processing, the corresponding control plane will be different. If this is a CU user plane packet, then its control will have to be from the CUC. If it is a core network packet, then the 3GPP core control plane is going to be managing it. If it is the BNG packet that we're talking about, its corresponding BNG control plane that is going to be responsible. And again, following up on what Saurav just talked about, if your fabric is P4 enabled, then you can actually realize this converged user plane as a P4 program running on your leaf spine fabric hardware directly. So that means then you have two tiers in this setup of control. You have the user plane control, programmatic control through ONOS or SDN control, and above that you have a second tier of control that allows you not on a packet level, but more on a subscriber and session level control through 3GPP or the BNG. Okay, so that takes us next to the control plane convergence. So with the exception of mobility management, which is distinct for 3GPP access, we can talk about authentication, session management, subscription management, policy management, admission control, and address management at the core be common across BNG and 3GPP core. So we can start talking about how or if we can converge some or all of these functionalities towards a converged control plane. And there's also ongoing work within 3GPP and Broadband Forum, and we will be closely following them, and we would do this in a standards compliant manner within COMAC. So then the platform itself is going to be exactly what Saurav talked about, where imagine a cord-like edge cloud where you have now two profiles, one for mobile and one for broadband, but both profiles actually also use a converged user plane and control plane. So the last thing that I want to share with you is details of the demo that we did at MWC this February. And this was a coexistence demo. So on a given edge cloud platform, ONF's core basically, we had both broadband access and cellular access coexisting. And in addition to that, we had our open source EPC, OMEC, as part of the demo. And we distributed both the 3GPP core as well as the end user services across multiple clouds. So this was truly an edge cloud and a central cloud demonstration and how they can work together. We had an ONAP integration. The services were orchestrated globally by ONAP. And we also had network slicing, including slicing of the RAN, done programmatically, overseen by ONOS, and again orchestrated by ONAP. So there were many participants in the demo. Deutsche Telekom, AT&T, Netsia, Acceleron, Infosys, GSLab, Intel, and EdgeCore all participated. And the demo infrastructure looked something like this. In Barcelona, we had an edge cloud, and that edge cloud basically had an SDN-controlled, ONOS-controlled fabric, and 4 servers. These all were 40-core Xeon servers, basically, And connected to that, we had an Edge Core OLT and also an ONU. And we also had a commercial outdoor small cell connected to this. And that was a split RAN solution. So we had the RU and DU together inside a Faraday cage. But the CU was implemented in a microservices manner. So it was 3 containers that collectively made up the CU, which was hosted at the edge in Barcelona. And Deutsche Telekom graciously opened up their data centers in Warsaw, Poland for us. So we actually used that to illustrate the Telco Central Cloud. Our Barcelona edge was connected via VPN to Warsaw, Poland. And in Istanbul, Türk Telekom had the Beijing release of ONAP running. So that was the second location of the Telco Central Cloud. So this was a 3-country distributed cloud demonstration on that front. And from a functional perspective, this was, the edge was entirely cloud native. Everything was Docker containerized, orchestrated by Kubernetes, and all of the monitoring was done by Prometheus, and we had Grafana for visualization. And we had Helm charts to specify the different service graphs that both cellular and broadband required. Just like Saurav mentioned, some of the ONF core components were running. So we had, in addition to Kubernetes, we had NEM, which enabled services control via both ONOS and Kubernetes using Helm charts. And ONOS was used not only to control the leaf spine fabric, but also access. So through Volta, it provided control of the broadband access. And through Program, it also enabled programmatic control of the base station, which in turn enabled us to do network slicing, including slicing of the RAN. And we had, like I said, a split RAN solution. So it had 3 containers collectively making up the CU. And our OMEC was distributed across the edge and the central cloud. So we had the user plane, the UPF, in Barcelona, and all of the control plane containers were in Warsaw, Poland. The Poland location was also cloud native. That was a second Kubernetes, independently running Kubernetes cluster. So we had 2 Kubernetes clusters communicating, and because the communication protocols were SCTP, etc., and Kubernetes ingress does not support that today, we had to use a VPN. And for an end user service, we had a CDN for multimedia streaming. So we heard about that as a good edge cloud use case as well. So we had a local streamer at the edge with hosting local content, and then a remote streamer with content archive, again, in Warsaw, Poland. So on that platform, we had 2 handsets, and these handsets were belonging to different network slices. One handset was doing multimedia streaming, and we showcased what happens when you actually request local content versus content from the archive, showcasing in real time the power of the edge. And the other user belonged to a download slice, and by using ONAP, we could in real time change the slicing profiles and observe that dynamically on the end user quality of experience. All right. So we've done this thanks to open source, really. I mean, it is the ONF community and the open source that helped us get this highly integrated demonstration in a matter of 2 months ready. And it worked very, very stably during our Barcelona event. The ONF platform, now that you heard SEBA and now with coexistence portion of COMAC, really you can understand that it is designed to simultaneously support multi-access technologies by just instantiating different profiles on it. It is also a platform that enables multi-cloud connectivity, which as an edge cloud platform it should. We also have, as part of now CORD, a 3GPP compliant, near production grade open source EPC that comes with the release whenever you download it. And CORD is unique in the sense that we also have SDNized the access, both for broadband and for RAN. And it is also a multi-vendor platform. So we use commodity hardware, but we can also connect to commercially available base stations, commercially available white box, OLTs, etc., and come up with an edge cloud solution very, very rapidly. Thank you.
Thank you.
Questions? No? All right. Thanks again.
They know drinks are coming. They know the drinks are coming.
I know.
All right. Thank you, Oz. So, as you know, we're following a little bit of a modified agenda at this point. We're going to have, before we call Roz up for the town hall, we're going to actually be served some drinks. So I think that would be popular, right? So I think that the folks are wheeling them in. We have drinks here. And then I'll introduce Roz, and then that should provide a more relaxed environment for people to do Q&A and have a real proper town hall, right? And then after that's all done, we can still go to the room next door and finish the happy hour till they throw us out, I guess. Then why don't we take about 5 to 10 minutes, and things are already getting set up in the back of the room, and then I'll introduce Roz and we'll start the town hall portion. Does that sound good? All right, thank you. right, let's have a seat, folks. You've had enough chance to get a drink. So, let's have a seat. It's time to get started again. That's the problem with letting people go to the alcohol. Oh, that's you too. Sit. All right. Okay. So we're now to the town hall portion of the program, and nobody's listening. Put a beer in their hand and their minds go to mush. Look at this. All right. Hello. Please sit, or at least be quiet. Yeah. You asked for it.
People, sit down, please, so that we can have our town hall. There are lots of great conversations going on, but let's have them all together so that we can share our insights with more people than just the person next to you. So please sit down and be quiet as soon as you can.
Thank you. Whoa, nicely done. Now I know who we're going to elect next time. Okay. You're definitely a better whip cracker. Okay, so we're at the town hall portion of the program, and Roseboro is going to help us lead through that. She gets to pick on anyone. No one is safe. This is just like being in law school. So if she has a question and you look guilty, you could be called upon. So now, before she gets to call on you, I get to call on her. So Roz is with Heavy Reading, and she's a principal analyst in cloud infrastructure and edge computing, those things that are near and dear to our heart. She's got nearly 20 years experience in market research, marketing, and product management. She focuses on how innovation and change are impacting the compute, networking, and storage infrastructure domains, with particular emphasis on trends that are very near and dear to my heart, such as virtualization, componentization, and can I say it? Convergence. So Ross joined Heavy Reading following 8 years at OSS Observer and Analyst Mason, where she most recently managed its Middle East and Africa regional program. And prior to that, its infrastructure solutions and communication service provider programs. She spent 5 years at RHK, where she ran the switching and routing business, communication services programs. And prior to becoming an analyst, she worked at Motorola on IT product development and radio and mobile phone product management. She has a BA in English from the University of Massachusetts Amherst and an MBA in Marketing Management and International Business from the J.L. Kellogg Graduate School of Management at Northwest University. And she's based in Chicago. So Cubs or White Sox? Okay. Does anybody here not know Roz? Oh. And so this might be one of the few times that we'll be able to see Roz. So I think we should give her an extra big welcome to the.
Don't give me that one. Don't give me eyes. All right, for a change, I'm going to sit. And thanks for sticking around. I guess the beer helps, right? Is this on? I can talk a lot louder, as you know. Okay, there we go, great. Yeah, so thanks for sticking around. I have some questions here, and I would like to stir up some controversy, because that's what I like to do. And I will have time for you guys to also ask questions of, not necessarily me, but of the other people here. So first thing I'm going to do real quick is a show of hands. I want to see who actually in the room. Service providers versus vendors. So vendors, who are you? Most of you. Service providers. All right, service providers, you're going to get called on. In fact, the first question is for the service providers. Given that the topic was transforming 5G networks with open source and disaggregation, want to know, we heard from service providers who are clearly all in on it, but I'm curious to hear from those service providers who may still be on the sidelines a little bit. who might be dipping their toes in open source and disaggregation to find out how important is open source to your 5G plans. And I'm hoping one of you will actually volunteer. I could look at Mirko and make you talk, but any of you that just raised your hands. Because we can get in a kind of an echo chamber. I go to a lot of open source things, and so I hear all about what AT&T is doing, what China Mobile is doing, things like that. But there's a lot of other people out there, so I'd like to get both sides of the story, if we can. Troy, we know you're on board.
I waited the requisite amount of time. I was trying to wait longer. But anyway, so I think most people were here earlier today. They know who I am. We have obviously made the bet from an ONAP perspective. And so as we start to deploy our 5G networks, we're looking to orchestrate that with ONAP. Our realization, as most people are on the, kind of realizing that as well, is it will be a mix of OSS, traditional OSS, BSS, and open source orchestration. The other big play, I think, is going to be in disaggregation of hardware and acceleration of the data plane. So leveraging FPGAs or programmable ASICs with things like P4 and other languages to really be able to get the level of performance out of virtualizing your network is, I think, going to be essential. So that's my 2 words. That's why I spoke first, so that no one else stole it from me. There you go.
Thank you for breaking the ice. Mirko, I will pick on you just because I know you, but
actually, something I was thinking about open source. So it's fundamental, but I was looking at big open source project versus picking open source components and building something around that. I think although big open source projects like ONAP are great because they create a capability that doesn't exist, and the creation process is amazing. I think we went a long way from the past, from different approaches. But I tend to think that it's much more agile to pick small components and build around that. Because also big open source projects tends to have the drawback then you're actually locked in. So which was one of the reason of not going for pre-built appliances, so going open source.
right, good point. Because you don't have to take everything. You can take just the parts you want. Any other service providers want to chime in on the importance of, or lack thereof? No one wants to talk. Need more beer.
Drink some more so you start feeling more chatty.
Okay, I'll ask a different question. I got a lot of them. That's what I do. Actually, Tom mentioned how telco is essentially leveraging a lot of technologies that are coming from the cloud world, which is predominantly IT. And so I guess another question is, do you think open source is in some way more appropriate in those environments than perhaps in telco? People telco likes to think that we're different. I guess I could say that since I've pretty much been a telco person my whole career. But when I go to the other open source things, they want to create something that everybody can use so you don't end up with something just for telco. So, just curious again whether or not you think open source is, it's fine for those guys, but it's really lacking something to make it more appropriate for telco.
I mean, I'll actually jump in.
Actually,
okay. I was going to say, if
I saw
someone's
a
got their
back
hand
there.
raised.
Thank you. Someone to break the ice.
Somebody from the ISP world. I think there's a situation where telcos, it's not necessarily the, whether it's open source or specifically built for telco. It's whether or not it is sufficiently engineered that the engineers think that it's quality. And I think that there's sort of a double-edged problem here. The one is that almost everything in the open source community and almost everything that built the global internet over the top of existing networks has always been an under-engineered, but it works. And I think sort of trying to find a way to not fall into over-engineering traps, to not sort of fall into this, version 2.0 never comes because it's, it's just never built to what people want, while still sticking to proper engineering practices, to proper documentation, to being able to deliver carrier grade, is the challenge. And I don't think that it means that it's possible to embrace open source in the telco world in the same way as it's been able to be done in other IT sectors. But it certainly doesn't mean that projects shouldn't strive to be acceptable to telcos. I think that's the the challenge, and it's a bit of a little bit of a challenge for the open source guys, as far as I'm concerned.
I could have an alternate opinion on that.
Since I have the microphone, I'm
Okay.
going to
So-
use it. This is the great part about running the mic. I mean, to that point, when OPNFE got kicked off, we were, part of what OpenEdge was doing was integrating stacks of components and also taking things upstream. And most of our early wins were actually going to OpenStack to explain telecom needs, help telecom people talk to OpenStack people with maybe a fewer acronyms when they were trying to describe their needs. I had a conversation with the OpenStack board once, and they were like, "Why do you people not speak English?" And I said, well, if English is made out of acronyms, we speak English. But I think the point is actually finding the areas of communication where you can get that across. Over the past 4 years, there aren't any gaping holes in OpenStack that are specific to telecom, right now. And so I think that there is a lot of work to be, there can be ways that the telecom people actually can influence things that may have started in more enterprise or IT to make sure they deliver our needs. And I saw your hand up, so I'll bring the mic back to you.
Well, I was going to try to get a word in.
I'll yield after a second.
Before you started, I was actually going to provide an alternate view that I think in a lot of ways open source is still ahead of where the heads of telecom are, and that it's not that open source needs to be special for telecom to make use of it. It's more like we're on a journey. Telecom was an extremely insular area of expertise, and there's so much innovation, there's so much going on in the open source communities, it's impossible to ignore it. And so we've been drawn in. But the telecoms are not doing CI/CD, not really. They really don't have software staff. They don't have folks that engage in, generally speaking, of course we got some developers, but generally speaking, they don't engage with open source the way most IT organizations do. And their culture, and at their own peril, if they don't move, if we don't move our culture to become more unified and converge with where all the innovation is occurring, right? In the cloud native foundation, for example. That's where there's so many people, so many more developers than we have that are from the entire IT world, and they're moving ahead very quickly. They're doing wonderful things. And if we don't learn to work like they do, we're going to be left behind at some point or another, in my opinion.
I agree with Tom's comment, but I want to go back a little bit to the gentleman's comment earlier around engineering for 5 or 6 or however many 9s. And I'm going to be maybe a little bit controversial here and say, to take a page out of Ross's book, to say we need to start thinking about things like chaos engineering, to assume that there will be failures and engineer a solution to work around those failures and survive them, not to avoid them. Because as we just talked about, there's so many innovations, so many changes, so many moving parts. That's just a fundamental change in philosophy, and it's a hard change for the ultra-conservative, historically telco mentality. So that's a challenge that for all the service providers in the room, and even the vendors in the room, that we should start to think about. Let's engineer assuming there will be failures, and make sure that we can survive them.
We have one in the back there, that's even better. Gonna get
Thank
my
you.
workout today.
So just to represent the vendor side, I'm actually working for a semiconductor company, but in my eyes, one of the biggest challenges that we have is CI/CD. So continuous integration, continuous development, keeping up with this moving target, with all those different community projects. Even for a hardware vendors like ourselves, it requires the allocation of many software resources to keep up with that, and that's a challenge.
You just mentioned my favorite topic, actually. I spent a lot of time doing compliance and verification, but I actually have a huge thing for CI/CD. And actually, within the open source world, actually having seen CI/CD like really, really impact changes and really improving quality and time to market, I've got the CI/CD religion like pretty heavy. So I encourage everyone.
No, just to add to what Tom and Troy said, I think the maturity of the open source is probably another aspect that we should look at as well. It's definitely the path we want to take, but how robust is the open source? I think that's definitely one of the concern, right? And I think that's where we need to focus and make it more robust. And also, I think Troy, you mentioned that meaning the legacy telcos, we've done it for so long, right? And it's hard to just go greenfield, right? So I think it's also the culture change plus as well as our requirements. Do we need the legacy requirements that we have carried for 20 years? Or is it time to, relook at things, not carry the baggage, right? I think that's another aspect.
Yeah, that's true. There is a lot of stuff that's there that probably doesn't need to be there.
Right. So
Right.
all you vendors out there, how many of you have gotten 500-page requirements RFP from AT&T?
Everybody.
That's right. And I better, how many do you think we actually made use of at the end of the day?
That's my guess.
To add to the same subject, besides chaos engineering, I think we need to think about go-to-market strategies and also learn from the IT industry. We recently started to attempt to go to market with beta versions that customers don't have to pay for. And I think that is also quite a great way to get things out faster and learn and then take it back and then perfect it at a later stage.
Oh, yeah.
That's true. I'm going to do another show of hands. How many of you guys in here are actually actively engaged with an open source project? Lovely. That's actually a little higher than I anticipated, so that's great. In an attempt to perhaps make the others who are not engaged feel a little more comfortable, does anybody want to talk about what it felt like when you first started engaging in terms of sitting down at the table with your former competitors and kind of learning a new way to approach solving some of these problems? Because I think that's part of some of the reluctance from what I understand. Some people are like, well, why would I want to give away, my company secrets or let my competitors know what I'm up to? Obviously, a lot of you were able to overcome that. So does anybody want to talk a little bit about that? Thank God for Troy.
Right.
I'll be brief. And I think, so when we think about our competitors, traditionally they may have been, the telco's competitor was the cable co, or maybe in some weird circumstance there may have been overlapping telco boundaries. But the reality is those aren't our competitors. Our competitors are the over-the-top guys that are monetizing the networks that we've built for over 100 years. And by the way, not only are those over-the-top guys our competitors, but they're also need to be our allies as well, which makes it extra, complicated. So that alone is a good reason to collaborate.
Good answer.
That is a good answer. Any of the vendors want to talk about that transition?
So about 2 years ago, we put in a spec for an open sled for the OCP carrier grade, and it was hell going through our executive team to say we're going to basically give out our IP to the world. And actually it worked out very well, because once we did that, we started aligning with other, what used to be competitors that are now partners. And from an AD-Link perspective, because we're in so many different market verticals, from telecom to military and so forth, we can't go it alone. We really cannot deliver one single product that fits everything. So the key is work with your enemies, make them your friends, because that's how we're all going to win. And not just in the hardware standpoint, but also the software standpoint as well, and providing more integration activities between all the vendors. It's worked for us. It's been working over the past 2 or 3 years, and I extend the challenge to not just our competitors, but our partners to start doing more and more together with really cool projects like this. but we also need to see revenues, AT&T and Bell and Canada. And we can do 1 million proof of concepts, but let's start seeing some revenue, guys. Let's start seeing, you know, the billions of dollars that are being on the table. That will entice a lot of people around.
Oh, of course. Of course.
It just dangled out there.
Exactly. Just kind of got that in there. Is there anybody who is not currently engaged, want to talk a little bit about perhaps why they're not? I will throw out a couple potential options just based on some of the research I've done. You know, sometimes it's just cost, you know, either in you know, time, money. Sometimes it's that they don't see any benefit of it, but I don't think most of you would be here if you didn't think there was some benefit to open source. Sometimes it's because they don't know how to get engaged. They don't understand necessarily what they could contribute. They're overwhelmed by choice. As we talked about, there's about 97 edge projects right now. So sometimes people really they just don't know where to start. Again, are there any brave souls who want to, or maybe their company won't let them for whatever reason. Oh, come on.
It's a safe space here, if you, come on.
I don't want to put anybody on the spot, but I actually am genuinely curious. Like I said, I spend probably, you know, way too much. And there's no such thing as too much time, but I spend a lot of time, like I said, within the open source bubble. And so I'm, you know, I've kind of got the religion on it, but I really am quite curious to know. And I'm sure they would be curious to know what's going to get. I think someone actually asked you earlier, how do you get more people under the into the tent on this? I mean, I guess
it's an internal problem too, right?
Sure.
Because, like I said earlier, we're 300,000 people at AT&T, and a lot of them have been there for much longer than I have, which is spooky, and they know how things should be, and this is just not it.
Right. Right. Okay. Well, you can tell us offline. You don't have to do it in front of the whole group. I still have more questions here. I don't know how much time we have, but is there anything that you guys came here hoping to hear that you didn't hear? This is kind of, you know, if we didn't have time to get to your questions during the presentations early. Oh, good.
Yeah, thanks, Rose. Tied to your point just a moment ago about one of the reasons some companies don't get involved is the incredible choice out there. And I guess the question I'd like to throw out for the community here is, what is the responsibility of a group like Linux Foundation to give us some clarity when there's duplicate things going on? For example, I still see ONOS all over the place, Open Daylight all over the place. We've got this, you know, new RIC controller. We've got the SDNR controller. There's a lot of duplication of work there, and I'd like some guidance for that, and I would hope we could get some from the open source community itself.
Sure.
Whoa.
Okay, that's fine.
This is fine? Okay, thanks. Yeah, it's true. There's a lot of choice out there, right?
Good answer.
You know, the thing is, choice is a good thing. You will never hear from the ONF that, hey, we did CORD, right? But why are there other options for doing the same thing, right? You'll never hear that from us. Because we believe that choice is a good thing, because choice often leads to competition. And competition often leads to innovation. And at the end of the day, we all win with innovation. So yes, for a while that things can seem confusing. I got this, I also got that, I also got that. Which one do I try? Well, you have to try something, right? But these guys won't buy products from just one vendor, right? They also want choice. So if they want choice in their proprietary solutions, why not have choice in the open source as well, right? So we believe that choice is a good thing. It has so far. They're around, we're around.
So do they really want choice, or do they just want to have some assurances for business continuity?
The business continuity for themselves, or?
Yeah.
Yeah.
I mean, I would argue that we have too many projects, that we have too many choices. What people really want is business continuity, and they want to have that through a ecosystem that is all working on the same project. So if one partner, can't fulfill their needs, that there's another partner right there that has the familiarity with the source code on the software project, or is a second source on the hardware project. If you have a lines down situation, you have a hurricane in Asia, you can't ship product, there's an alternative. So I actually think that we have too many projects, that we need fewer, we just need people working together on those.
That's a great comment. Okay. So I think I don't know, I'm a great in the middle, on the fence kind of guy. AT&T still hasn't found a STN controller we didn't like. And I think we're busy creating some new ones. And the thing is this, an STN controller is like a hardware driver to me. It has a certain set of characteristics and it's good for a certain application. And I might choose this one or that one depending on what the purpose is. And there are many good ones, and I expect there to be more good ones. And I don't expect the world to be locked down into one ring to rule them all, so to speak. There is also, I think,
Tom, using that example, you can have a controller that has different options, and that when you build binary, you build it with certain options. So, you can have a single software project, open source project that has different features.
Yeah,
but no one argued when Android came out that it was a bad thing, right? iOS was already there. Why was there a need?
not so open.
Industry talks about this.
iOS is not so open.
Right.
No, but
That might be a bad
what
choice.
I'm trying to say is that no other industry tries to say that there shouldn't be choice.
There is a consideration to be made here. I think changing a mobile phone is quite a different thing than changing an orchestration platform. I do agree there is a lot of choice out, and you could argue too much choice. One thing that should happen, I think, is some of the open source projects should start talk to each other, understand where the overlaps exist, and also try to think about where you can ensure this continuity. If you want to move from one platform to the other, you need to be able to do that. I think I was thinking about Own Up again and open source Mano and all the other initiatives, and we were thinking about which one is going to win, who do we want to back. That's the consideration we make.
Yeah, just to follow up on that, it's surely a problem if you have competing projects that are incompatible with each other and you end up creating this sort of uncertainty problem in the market, or if there's vanity projects, if there's suddenly a proliferation of vanity projects to solve one problem that are wholly incompatible with each other, that break business continuity, that cause all of those sorts of things. But that's got nothing to do with whether it's open source or not. So I think there's something intrinsically good in open source in that it allows for choices to be created, and for the market and for the engineers and the software developers and so on to quite rapidly actually make those choices. If you look at projects that get rolled back into each other, I think if you look at it over a 1 year period, you might see a particular forking problem. So everything's getting forked off from each other, and it starts to look like you've got too much choice. But if you look at the same technology over a 10, 15 year period, the situation's quite different. We can simply look at the Linux kernel and Android scenario on that front. They're hard forked from each other, but they're reinforcing each other, after a couple of months and after everybody grows up and puts their ego behind. And I think that can be said about a whole bunch of projects. I don't think it's intrinsic to open source. I think it's intrinsic to ego that we need to move.
I agree. I think that's a common, as being a technologist is my day job. A very common pattern is to see a lot of chaos early in any innovative activity. The chaos is exploring what the vectors are and what will work and what doesn't work. And over time, as you figure out what the best one or two most likely solutions are, they coalesce. And I think the same is true with open source, that if there's something new and really a new innovative area, nobody really knows which way it should go. Lots of directions need to be followed. And they need to be followed. It's painful. It is painful. It's not efficient, but you need to follow them down if you want to have a good outcome at the end. I believe that things will also coalesce, that all these STN controllers and, in 5 years, we might not care about SDN or controllers anymore. Sorry. Something else will come along, right?
Okay, so I would say to the general comment, there's a solution to this problem, actually. And what the collection of communities could do is to be more specific around what the functional role of that open source project is solving, and to agree on that. So essentially agree exactly what the standards, all the standard communities did in the past. So let's take a page out of that book and say, I'm going to build a box around it, and I'm going to say what the interfaces in and out are, and then I'm free to do whatever I want inside. And in that way, a service provider can say, okay, today I'm going to use ODL, tomorrow I'm going to use some other SDN, and that's okay, because now that can work in the ecosystem that I've built in my environment. So that could be one way to help us solve that problem. And I think that having that choice is actually essential, and without it, it's going to stifle innovation. So.
So I've been around a long time too. I think there are others doing open source, but I'm 20 years or so. And I would agree with Bill that there are too many projects. But I'm going to argue both sides of that equation. I've seen projects created because there was a technological approach that was different. I've seen projects created because there's a difference in governance, a difference in way of doing it, right? I mean, ONF does a curated open source, right? And while I've been doing a different kind of open source for a long time, I'm not going to say that that doesn't work because I've not seen it tried. So, hey, let's give that a shot. There are reasons why you want to do different types of projects, okay? But fundamentally, the idea, the purist in me, as an open source guy, says the point behind open source is not to compete with one another. It's actually to come together and create something that is good for everybody, and it's not particularly differentiating for anybody, and so we can build that together, we can build that strong function together, and get to the solution we're actually trying to get to much, much faster. The problem, and what I see is a significant proliferation of open source projects in the last several years, we are dealing with our own success, right? This open source thing is great, let's go start another project. Because I will tell you that one of the things that I don't think this industry has grasped very well yet is it is not the case that open source gets you to the first solution faster. It actually gets you to the first solution slower, because it's hard to bring everybody along. It's hard to get that platform and that modular structure so that anybody who needs to use this platform for a particular use case can get their problem solved. That's hard, right? We've combined OpenO and ONAP, or ECOM, right? 8 million-ish lines of code. It's great to have seed code to start from, but that code was written, a lot of it, was written to solve one particular user's needs, right? To get the rest of the community around and to bring lots of other operators and vendors in, you have to end up spending a ton of time then educating them on what that code does. What that code might be changed and refactored and modularized on how it could be used for others. That's a lot of work. And it slows down feature development because we've only got so many developers. And we're partially in that mix, right? It's easier to start a new project, or it's even easier to start a new sub-project within a project that does something near that is already done somewhere else. But if you don't have to ask anybody about the code that you're bringing in, it's just easier to get there faster. So there's a collaboration that we're still missing, that we need to do more of, and say, where can we be common? Where are we common across projects, across sub-projects? And that is an effort that, again, it actually slows development down initially. But over the long term, it makes it so that everybody's working on that same code base, and so then you get the network effect. Because these folks are working on something over here, and these folks are working on something over here, and in the end, they both need what they've done. Okay, and that's the great thing about open source, and I've watched it in Linux over the last 25 years, right? The supercomputer guys, they really didn't like the small footprint guys, right? These guys were going for small power, small footprint. The supercomputer guys were trying to figure out how to shove 256 NICs in a mainframe, right? So they were much different problems. In the end, they both leveraged each other's code. You noticed when you had a phone and we went to NUMA, we went to multi-core, we went to 64-bit. It took nothing to get there because the supercomputer guys already figured that out. Now the supercomputer guys now do all of their management of their CPUs and slow things down to save power and heat, and that was all stuff done by the low footprint guys. Right? So these strange network effects happen when everybody's working on the same base, as opposed to creating your own software. We should try to get to that, recognizing initially it's going to be slower, but the long term it's going to be faster.
Yeah, I think some of I think some of the aspects are covered. There's truth to both sides, and I think most of the vendor community, they must be contributing to the open source in some way or the other, right? There are many projects that are provided or led by them as well, right? Give back to the community. But I agree with, there are just too many of them. You cannot have 300,000 workforce in every single vendor community, right? So it just, the scale of it, and I think you mentioned ONAP, eComp and OpenO, right? It was Converged, so there are reference architecture. If we can get to that, there are open source tools and there are many of them, right? So getting to compliance to every single one of them, getting certifications around every one of them, participating in every one of them, getting the skill set upgraded for every one of them. It's just too many of them. Ultimately, it's business, right? Not academics, to the ultimate convergence, right? So there's convergence, sooner it happens, the better it is, I think.
Yeah, I have a question to Rose.
Really?
Yeah. So this session is about open source's disaggregation. Do we plan to address disaggregation as well?
Sure.
I think it's not less challenging and even more confusing story.
Okay, what would you like
I'm
to
sorry to stop this
No.
discussion, just to make sure that we arrive to this point as well.
What would you like to discuss about disaggregation?
I think that if you ask opinion what is disaggregation in this forum, you will have at least 12, 10,
12 different
hundreds,
answers.
whatever. I think that it's very interesting to discuss. The same way as Mirko defined the open source, let's say, the small pieces of software projects, I think disaggregation is also pretty confusing story, and it's worth having some opinion and also maybe to converge in this direction. Just sorry for interrupting the very lively open source discussion, but I'm just waiting this disaggregation
waiting for the
part.
disaggregation questions. I said, why don't you start with what you think disaggregation
Okay, fine,
is?
I can
How about
do
that?
this, yeah. I think that disaggregation started from software and hardware decoupling. And many companies called it disaggregation. Okay, and this is just maybe it's disaggregation, but most probably it's a very early stage of disaggregation. And then I think that you address in your presentation very nicely that disaggregation goes, let's say, to some kind of microservices, and I think that Tom also mentioned this, and maybe this will be also somehow expanded to hardware in the very kind of the seamless way. So I think that disaggregation, it's a very promising story, yet it's not so clear today. And so therefore, I think it's not less interesting in this open source to discuss today.
Oh, agreed. Maybe I'll throw it to some of the service providers about which, I guess, dimension of disaggregation do you think is to be the most beneficial? Again, is it just simply the hardware-software disaggregation, or is it the re-architecting of the VNFs to use microservices and shared services and things like that? Disaggregation, like you said, it's kind of a continuum, right? And I think somebody mentioned, I think it was you that said, you disaggregate all this stuff, but eventually it all needs to be put back together again, which is also a huge problem.
I will assert what disaggregation is not. It is not taking the code from your existing hardware solution, slapping it in a VM, and calling yourselves done and wiping your hands, going,
It used to
woohoo.
be. It used to be.
Right, that's not enough anymore.
That was a good first step.
It was a completely reasonable first step.
Right.
First step, baby step. Oh, beautiful. Uh-oh. Now it's on.
This is some practice by China Mobile. It's regarding integration part. It's to make it worth we have for OpenStack itself, you know, China Mobile is the largest mobile provider in the world, 930 million subscribers. And then we have a different deployment in different, we call the province, here we call states. So for OpenStack, we have, so far after reduction of the number of providers for vendors, we have 5. Before, more than that. Now the thing is like, for that things, and then the vendor A cannot control something or do the automation from vendor B. Vendor B cannot do vendor C, C cannot do D. So what we have done is to provide some integration tool to define some hardware, not hardware, is some abstraction layer in order to provide some interface so that vendor A can do something through us with vendor B. This is only for OpenStack. Now, if you enlarge the picture to look at other open source projects, so the thing is really like, even if we can lower down the CapEx maybe, but the operation, you know, efficiency about these things, and then when you consider everything together, you know, we are really seeing something that is very challenged. So, yeah, so that is a thing we have done, but now it's more and more open source projects. Just look at the, you know, here, like on the RAM part, on the Xcode part, and the mobile core, everything open hardware, open software, solutions, so everything together. It's really a challenge.
Right. Right, no, understood. It's creating additional work for you guys in the interim while things still get sorted out, right?
Oh, yeah.
So anyone want to go real quick back to that disaggregation thing? Again, like, so there's a lot of different dimensions of it. Or I get maybe perhaps ask what the service providers are looking for from that perspective. Sometimes we do things just because they're kind of cool and fun to do, but
no, I don't think so.
Happen.
Not with disaggregate. While she's walking over to Troy, in my opinion, disaggregation is really about hunting for the holy grail of reuse. That when we've had appliances, and we've got a ton of appliances in our network, they're all bespoke. They all do just one thing. They're all one-trick ponies. And disaggregation is really about teasing out individual capabilities and then reusing the ones that are hidden in and buried in all of those appliances over and over and over again. That's what I think. Each time with a different operations interface, a different EMS, and a different, you know, it's a waste in a lot of ways in our industry to duplicate functions in dissimilar ways when disaggregation might allow you to have the common functions that are reused over and over.
So you're talking about software disaggregation, like the hardware software. That's kind of like
I consider it a done deal.
Right, and that's pretty much
like when Heather said when they took the code and ported it to x86.
To an x86, done, right.
All right, so that was the first thing. And now it's time to tease apart the networking, big, humongous networking blocks called gateways, for example. You got like 700 features. Each one.
Of which you use 3.
Well, you know, on a good day.
Right.
So one of the, yeah, I think one of the key things with disaggregation as we kind of evolve from version 0.1, which is when we took the monolithic code that was sitting on a purpose-built hardware stack, you know, and moved it into a VM, and we start creating microservices from that, decoupling our, you know, even more so than just control plane, data plane, but individual functions, is we can start to, so we started off and said, let's virtualize and move everything to x86. Commodity hardware, makes sense, blah, blah, blah. So we did that and then said, wait a minute, there's a whole bunch of functions that don't run really well on x86, you know, that does a lot of good things, but there are things, so we have to break it all apart, and that to me is what the next level of disaggregation is. We have to break it all apart to small enough pieces so that we can actually target the appropriate hardware target architecture to match that specific function. It's still reusable. I can, with GPUs, use that for some graphics data analytics. I can use it for AI/ML. I can use it for whatever. My FPGAs I can use for data plane. I can use for other things. You know, standard control plane stuff I can put on x86. But we have to break it apart to that point to actually make it really get to that level of efficiency that we were promised when we first started talking about this, the billions of dollars of savings that we know we didn't realize. So we got to keep pursuing that. And and sorry, I don't remember the gentleman's name from China. TJ. So TJ was talking about the orchestration problem. So we have to be able to automate all of that, because when we take 8 million lines of code and break it down into very small microservices, unless we have that 100% automated out of the gate in terms of ZTP and then lifecycle management, we're going to fail. So anyway, that's my 2 cents.
But what you're asking for, I'm sure, I don't think that anybody disagrees that that's what ought to be done, but for the people that are responsible for doing it, that's an awful lot of work. Yeah. And that's the pushback I get when I kind of challenge the vendors. I'm like, so when are you going to make your VNFs cloud native? It's a big ask.
There are vendors who are doing it.
True. True.
That's so for the vendors in the room, that's a differentiating factor.
Yeah, I was just, I think one way of thinking about disaggregate, rather than, thinking of hardware disaggregation and software disaggregation as different things, I think a conceptual way of thinking of disaggregation is that it is making your ability to perform a particular function more robust. So, whereas in an old, dedicated hardware appliance environment, the particular appliance, you had no robustness because it was dedicated to particular hardware. So once you've achieved, virtualization is one way to achieve disaggregation. Microservices is another way to achieve forms of disaggregation. But I'm not entirely sure that once we've got certain of these microservices outperforming some of the functions and some of the appliances, and once we've got, hardware properly down the line, and I think we're pretty damn far down the line with hardware, I don't know what other means of achieving disaggregation there are. And I don't know if we actually will be able to achieve the levels of disaggregation that we need for robustness of functions. If we're not going to find sort of a headache in 5 years' time or so. It is concerning to me.
Oh, I got 1, 2. There's one right behind you, Heather.
I'm with a hardware vendor, so I can only speak about the disaggregation on the hardware side. But what we have found is in hardware, at least in my mind, it's a bit easier because breaking apart the pieces to making all of it Lego-like pieces that you can connect together, everything should play together. An x86 or an ARM, a switch from Marvell or a switch from Broadcom, an FPGA from Intel or Xilinx, they should all play together. So if you think about a backplane or some sort of an interconnect between them, making it a Lego piece, which is just modular, would give you that disaggregation on the hardware. Now you only need to make sure that those vendors know that they need to play well together, meaning I need to be on a board with this guy. I cannot, he's my competitor. No, you need to work with this guy. Your solution needs to run very well with that guy. And I think it's up to the guys that eventually are making those decisions, which is usually the tier 1, tier 2, to tell those hardware vendors, look guys, if you want us to be your clients at the end of the day, you need to make sure that your SDK works well with somebody else's SDK. And then people like us can just put it together in this Lego-like approach where everything is touch and go. You just pick and choose and build it. We're already doing that, but I think there's more to be done. But as I said, the hardware side, in my opinion, is easier than the software side.
Hi, I'm your competitor. Let's have a beer.
I just want to disagree that the hardware part is the easy part. I think it's a very important part, and this is just to continue what Troy just said, that actually the current white box approach is not relevant anymore. So it means that to consider that everything could be done on a very simple white box, I think it's very naive. So it's clear that it's required certain hardware acceleration and all the other stuff. So I think they are just facing a very new stage. What does it mean actually a white box? And it will be a redefinition of this approach.
Oh, we got a new voice in the back.
Actually, do you mind grabbing?
So from the service provider side, maybe AT&T's got I know you guys have a whole army of software developers for all the open source and disaggregation projects and that. But as a service provider, I would almost say that we don't really care. it doesn't really matter if it's open source. It doesn't really matter if it's aggregated or disaggregated. What really matters is if we can achieve our goals of providing service. So some of the complaint around, maybe the telcos aren't moving fast enough, well, that's based in what's the use case for changing the network, right? Why would I rip out all these monolithic gateways? Yes, they're inefficient. But what is that use case? What am I gaining for that? All that activity, what is the service provider getting at the end of the day? From the vendor's side, solve my problem, and I really don't care if it's open source or not.
So you're saying you're happy with the status quo?
No, I'm saying I have use cases. Maybe it's to provide a 5 nines reliable network, 24 hours a day kind of thing. Maybe it's we need a certain megabit per second or gigabit per second network. It's I need so much latency requirements. Those are my use cases. So what does open source do? What does disaggregation do? What do those things do for me? And why would I want to put that in my network?
Yeah, I think the scalability aspect of that, right? Someone wants more latency, someone wants just the use cases, 5G, and
So you're saying that you have use cases and you don't care where it comes from, right?
Right.
Okay. So that's fine. Yeah, that's fine. Good.
It doesn't change the answer. It absolutely doesn't. In fact, it reinforces the answer.
Which is?
Your comment reinforces the answer.
just the scalability aspect of it, right? If you have to solve one problem, it may have different shapes and forms. That's where the disaggregation, scalability.
Okay.
Yeah, I have a more general question here. So I'm from Phaser JMA. We are a US-based 5G RAN company developing cloud-native disaggregated RAN. My question is in Japan, if you know Rakuten. I just came in late, probably that was already discussed here. So they are deploying a disaggregated cloud-native network. But they did not need to wait for like the open source to be ready, or while we are doing all the talk, it looks like everything to deploy a cloud-native disaggregated RAN or core network is already there, if the willingness is there. The thing is, Rakuten is an IT company, right? So they know cloud-native. So it's so I think earlier you made a point that we need to change. Probably we are not able to change, like the telco world. So maybe some outsider need to come in, like Rakuten, they need to show us the path, and then we just follow it. While we have been doing all the talk for almost 7 years, they just came in last year. Now they are deploying a cloud-native network that's going to go live in October this year.
Well, well, starting greenfield is a completely different proposition, right?
Yeah, so my point is, okay, so Cisco has their cloud platform, they have their orchestrator, they have their VNF manager, VM manager, everything Cisco brings in, right? Radio comes in from Nokia, RAN from Altiostar, Red Hat is there for their virtualization and all that. So they are able to bring the whole ecosystem like one operator and make that happen. Maybe that is the way it needs to be done, rather than us sitting in these, just having these discussions. No.
I can't say you're wrong. I'm leaving it to.
Yeah, and your question about greenfield, 5G provides us the opportunity to deploy greenfield, right? Why, I mean, so we do network all the time. We know 5G can be overlaid very nicely over the existing 4G LTE, while you can have all greenfield 5G. I mean, you can still have the interface to do dual connectivity to the 4G LTE network. You keep your old LTE network the way it is, right? 5G provides you an opportunity to go greenfield. Because in your central offices, you have the old equipment. I mean, you can overlay a greenfield cloud native network if the willingness is there. In my view, it's the willingness that is not there. That's the hurdle. It's not like the ecosystem or the ingredients are not there to deploy a cloud native network.
Right, you're saying it's not that the lack of technology, it's a lack of willingness to just go ahead and do it.
Exactly,
Right,
yeah.
okay. Bill, I'm gonna let you take the last word on this because we are just about out of time. I think there's still
Thanks.
happy hour over there, but go ahead, Bill.
I want to go back to the disaggregation. So I think on the hardware side, on the hardware side, our biggest challenge for disaggregation is still ahead of us. So, you know, we haven't solved the disaggregation of processor and memory and accelerators. You know, we still glue those together with, you know, PCIe. We can't, you know, we don't have a processor agnostic, you know, bus to stitch those together. We don't have memory coherency. You know, so those are the challenge that we have on the hardware side. I think we did some kind of low-hanging fruit in networking by separation of hardware and software. And we learned some lessons from that. You know, it was relatively easy to, you know, to separate the operating system from the hardware. You know, we did the abstraction layer with our switch abstraction interface. And then we start to build, you know, stacks on top of that. And you know, and we found that we actually had to re-aggregate projects. And we had a switch abstraction interface project that was, I don't know, 3 or 4 or 5 years old. I don't know, how old was it, Jeff? 5, 6 years old? Something like that. You know, we actually, that project now has kind of been merged back in with Sonic, because you have to have that, you know, you have to have control of the APIs to write your applications on it. So again, too many projects, putting things back together where it made sense. So at the hardware level, we're still got a lot of challenges to disaggregate the hardware. On the software side, we can see how there's opportunities to put things together. And the other thing that we started working on a few years ago was the embedded firmware. So think of it as BIOS or BMC. And, you know, that was a can of worms. You know, there was a lot of hands raised that are involved in open source software projects, or involved in open sourcing. Some other people didn't raise their hand because they're not involved. You know, what we found is that we started to peel the onion on this embedded firmware is it was hard to find, you know, first off, as you kind of peel away that binary, you know, you find that there's a lot of embedded binaries in there. And then you can't find who actually developed it. And you really don't know what the code looks like because you can't see it, and you don't know what security issues you have. And so, you know, if you're working with you know, closed software, you should be asking yourself, you know, how secure is it? How robust is it? What is your business continuity plans for that? Because I think that when you start to ask those questions, it's hard to find those answers. And we've been digging through that for about 1.5 years with server initialization. And we're at the point where we can actually start to see light at the end of the tunnel. And we think by 2020 or 2021 that we'll have a completely open source solution for platform initialization. But it's, you know, it's required a lot of work to disaggregate it, and then in a disaggregated fashion it's not good for anything, so you have to re-aggregate all the ingredients back, and you have to know what you're putting back together, and you have to get the licensing, you know, correct for redistribution. So I think at the end of the day, our goal is to re-aggregate a lot of this stuff, but you have to break it apart first. And we're at different phases of that. On the hardware side, we got a lot of work to do. You know, we think of it a lot, you know, if you kind of look at it superficially, it's like, oh, we did the hardware, software, you know, disaggregation, but there's a lot more opportunity down at the low level, particularly with accelerators, You know, the reason you disaggregate is that the technology treadmill is different for general purpose processors, for accelerators, for memory, for bus structures, and you really want to take advantage of that technology treadmill and get the technology deployed as quickly as you can. And in a completely integrated, hyper-integrated solution, you can't do that. So you have to break it apart. And the challenge is, how do you break it apart, have everything play together, and be able to put it back together so that you're literally introducing new technology into your ecosystem, into your factories, every 12 months or so.
Okay. And with that, I think we're ready. Thank you, Bill. I think we're ready to wind down.
So I'd like to pause for a moment and thank our fabulous compere of our day. Tom put a great deal of effort in helping these three organizations pull together the plan of the day, gave insight, and has obviously been up on stage all day, not being able to go off and do other things, and you've done a fabulous job, so thank you. And also Roz, let's give her one more round of applause. As Tom alluded, this might be this is our last telecom event with Roz, so make sure that you tell her how awesome her entire insights to us as an analyst for our industry have been for a very long time. You're killing me, Heather. See, I'm giving you eyes now. We've got a happy hour next door, so continue the conversations, have one-on-one things. If you heard speakers talk about stuff that you want to ask them one-on-one or things that people brought up in this session, we have the opportunity. There's a lot more wine and beer, and have fun.